The universe is calling you. The universe is calling me. It speaks both day and night. It's full of dark and light. And I've heard others call from light years away, and they're real and they're here. Space and time are instantly clear. Planets spin, grids in place. We can travel through space, fields and forms, math and voids. It all sings with one voice. It's boundaries set, foundations laid. Sound was heard, matter made. Solar systems from afar. Names and numbers for the stars, and I've heard others call from light years away, and they're real and they're here. Space and time are instantly clear. Planets spin, grids in place. We can travel through space. It's the Lord's.
Hey everybody, welcome to SkyTour Livestream. It's me, Mark D'Antonio, your tour guide to the universe, I guess you'd call it, the universe live in real time. And as always, with us, I have Daryl. Hi Daryl, how's it going?
Hello, Mark. How are you? Sound like you could use a Ricola already.
Yeah,
Hello, everybody.
Yeah, everything's fine. My voice is a little bit raggedy, but you know what? It's because I'm trying to do all these things like you see here. We love what we do. So how is everybody doing? I want to say hi to Renee Cruz, who was the first one here. Tim F. Hey, how you doing? You almost made it first. Michael Hedrick's with us. Nice to see you. Daisy and Zoe are with us. Great to hear from you guys as well. And Calybos, our friend Michael from SpaceX, is with us over there. And hopefully Tiffany is sitting right next to him, watching and having fun. And we're going to have a fun night tonight. We're going to look at a few objects. I took the liberty of focusing the system already, and it all looks pretty good at the moment. I'm just kind concerned about the delays in getting our view. Let me get my view back again. Sorry about this. We're gonna do this. Do it right here. Just a minute. So that looks fun, and then we'll come back to this. All right, and I'll take care of you in a second, Daryl.
Okay.
And now what I gotta do is adjust this. There we are. Okay, now let's hope this continues to function right. I've been having some issues with it not wanting to cooperate sometimes. That's all right. It'll work.
All right, your screen went small again.
Yeah, that's what it is. Can't help that. All right, let's try something here. All right. So as far as what we're going to look at tonight, if some of you saw my post from the other night, you saw that I did a Orion Nebula Running Man composite mosaic. It was really nice. So there goes a nice satellite. Michael says, Calybos, remember to like, share, and subscribe. Please do. We run on your support, so this is really cool. So let's go see. What's
You
that?
gonna make it? You need some tea with honey.
Oh, I know. I'm just I'm just working at it here. We're gonna make it work in a sec. I also have to bring up I'll bring up our I'll just talk softer, that's all. I'll bring up our planetarium. Okay. Here it is. And now there's where the telescope is pointing up there. But I always configure by disconnecting and reconnecting. Go, because sometimes it lies about where it is. All right. Now let's just do a quick hunt over here. Let's go see if we can grab Jupiter and check it out. Telescope's on the way. It's heading in the right direction. In our lower camera, you can actually see Jupiter. The telescope's probably blocking it right now. Oh, I made a mistake. I did not put in, or actually shut off one of the features that I don't like. Is trying to auto center, and it never gets it right. It used to, but it doesn't anymore. So I'm going to stop it, and we will go and take care of just setting up our parameters here. Okay. So we're digging into our guider rates right here. And we're going to tell it to change its guiding rates to what I know works. Okay, our right ascension, which is our east-west direction, is going to guide to a certain rate, and now we're going to change the declination rate, which is the north-south direction, plus 90, minus 90. And so it's going to be 22% of the... All right, here we go. And then we turn off that high precision stuff that's not working too well. It used to, and I don't know why it stopped. It's probably something buried in the hardware, because when we used to have it working before, it was great. But it was problematic. All right, so here we see our numbers. So we're guiding on this star field wherever we are, and where that is going to be near Jupiter, but not at Jupiter. So now let's tell it to go to Jupiter, and it'll go straight to it. That's my guess. So we should see Jupiter show up, and it should be pretty bright. And there it is. And while we're here, we might as well try to image it and see what we get. So you had to be in southern Florida to see the disappearance of Betelgeuse.
Yes.
And so we couldn't do it. We were hoping that P&K Space Imaging would stream, but they weren't doing it either, so we didn't get to see it. Okay, we're turning the gain way down. Again, as we've talked about before, when we look at these parameters, the ones that are most important are this one here, this is the exposure time, and this one here, which is the gain, the sensitivity on our sensor. So we're monkeying with those. So I turned the gain down to 0, and now you'll see that it's still too bright in our view. So we have to drop our exposure, this other parameter I showed you, until we drop it down just enough so we can see the disk of Jupiter without overexposing the disk of Jupiter. This is a very sensitive nebula camera, so trying to do this. Remember how big that spot of Jupiter was? It was huge in here. That's how much we saw. Let's zoom in now. Okay, we're gonna bring this up a little bit. Bring up the exposure a little. I'm actually gonna bring the gain up to 50 and then drop the exposure back a little. And we'll check it out. Actually, I'm going to do this. I'm going to drop this processing because that's going to make it even more difficult. This will be much better. We can have better control this way. There we go. Notice that we've got, you can see some moons, and as we drop the exposure, the moons will disappear, and then the cloud bands and zones on Jupiter will appear.
Io to the right. Europa is supposedly in front of the planet right now.
Okay.
Ganymede just to the left, and Callisto way off at the far left.
Yeah, is the great red spot just to the lower right, by any chance?
Stand by. Great red spot's not visible right now.
Okay. All right. So there you can see. Remember, we're shooting at f2 right now, guys. So this is a wide field camera, but because we have so many pixels crammed into this camera, we can take tiny Jupiter as it appears on our sensor and actually get some detail out of it. This is actually pretty incredible. See? And right now, Europa's in front of it, right? That's what you said, Daryl?
I'm sorry?
You said Europa is in front of it?
According to JavaScript Jupiter, it is.
Okay. Let's see if we can get a hint of something in the front. Now, yes, this will be way out of focus. I see something here.
It should be down, farther down.
Okay.
Io should be, it's pretty much straight down below the center of the planet, about halfway to the lower limb.
Wait,
Excuse me, Europa.
okay, so it's down here.
Io's off about 1 Jupiter diameter to the right.
Okay.
Ganymede about 1.5 Jupiters to the left. And then Callisto way out to the left.
So, okay. All right, so in moments of perfect seeing, which you sometimes get, it fluctuates. Sometimes you actually end up seeing that rare moment, those magical windows of clarity. And those sometimes show you that you can see objects in here that you just didn't expect. So every now and then I see some hints of other detail in here.
You were right about where Europa is. If JavaScript Jupiter timing is right, sometimes it's off a few minutes.
Okay.
Yeah, if you go from the lower limb about a little less than halfway up to the equator.
Okay, so is it in the dark band?
No, it's in the white below.
So
the
it's in
dark
here.
band. And a little bit to the right.
Okay. Since that Europa is
Right about
white
there.
and bright, in moments of perfect seeing, we should be able to get a glimpse of it. It's tiny, but we should see a glint. It'll be a pixel. It's not going to be a lot. But I don't see it. I mean, we could actually zoom in 800% or more. We're at 1200% on our sensor right now. So technically, Europa's right here.
A little to the right, to the left of that.
If that's correct, yeah. Yeah, if that's correct. Well, it's interesting because I see a consistent blurry blob here in the images. You see that? There's like a consistent blurry blob that's here that's not elsewhere. I wonder if that's an extended artifact of Europa.
It could be. As I said, JavaScript Jupiter sometimes it's off some minutes.
Mm-hmm.
Uh,
But this is actually...
I would think Europa would be pretty evident. As you said, I mean, it should be like a bright white.
Well, it's bright, and so, you know, Jupiter's brightness is going to overwhelm it, but it's going to add to it, so it's going to be blended with Jupiter. But as we zoom in, there is a consistent spot right here that you see right there, and that consistent spot, we're not looking at that as being the big circle of Europa's disk, but it'll be a tiny spot in here. See how it's there? It doesn't move. You know, it stays right there on the planet as the planet shifts a little bit. Really odd. Hey, Genghis, how you doing? Hey, Mr. Django, how you doing? Mr. Django, is your name Steven by any chance? Let me know. So we see a consistent fuzz right here that is different. It's a spot, not sure what it is, a darkening. But that's the biggest planet in our solar system we're looking at right now.
You could line up 12 Earths across Jupiter at the equator.
Yeah. It's a good thing there isn't a storm that's the great red spot size on Jupiter that would envelop the entire Earth. Hey, Pete Bods, how you doing?
The red spot's shrinking. It has been for a long time.
Mm-hmm.
Few
Let's go to the
decades ago,
moons.
it was like 4 times just a red spot. You could fit 4 Earths inside the red spot.
I remember.
And
Are we going to look
it's
at...
much
Go ahead.
smaller now.
Yeah, it is smaller. It's been waning. Okay, we'll go for the moons now. Okay, so this here is Io. This here is Ganymede.
Yep.
And this is Callisto.
Yep.
Notice they're in a line. There's like a mini solar system around Jupiter. And in fact, for some star systems, we actually see that because the stars are so small, sometimes only slightly more massive than Jupiter by minimally 80 times. The stars themselves may have planets that go around the planet, or may have planets going around the star. That's similar to Jupiter's moons going around Jupiter. It makes more sense to talk about. It makes more sense to talk about Jupiter and its moons than the sun and its planets when comparing it to some of these smaller systems. The dynamics, the resonances. It's more important, in fact, to talk about Jupiter and its moons because they're more comparable to these small stars. Obviously, there are stars that have planets around them that go around the star in hours, in just a short string of days, and that's their year. Remember, that's their year. Here, they're measured in just hours. But when you talk about, when you're talking about stars, it's weird that you have planets that only take as long as the moons of Jupiter go around Jupiter, in a way, to go around their star. That's what happens, though. That's what happens, And the universe is strange, and it's been a really exciting, interesting, ride, learning about all this stuff in the past. I'm going to increase our gain here, that magic parameter I told you about. That's the sensitivity, and then I will correct for it, get the actual value. Okay. Now I'm going to increase our system here to go back to our 1 second. The 1 second is just an arbitrary value that I chose. Now that I've got, as you can see, now that I have Jupiter in here, and I'm looking way up high in the sky right here, I will refocus the telescope. I did that before, but I'll do it again. So we'll get off Jupiter right now. I'm going to go a little higher in the sky. You can see the telescope moving over my head right here. There it is, right there. Now, I will pull our focus out and then let the system decide what the right focus is. Now, the reason I do that, you might say, well, wait, you already focused it. Why are you doing it again? Well, because of something called mirror flop. And as the telescope is sitting horizontally, the mirror is not under any kind of pressure. But when you go upright, the mirror can change position ever so slightly. You couldn't see it with your eye, but it would make it so that the telescope is out of focus. It's imperceptible to your eye, but very perceptible to an instrument like ours. Mr. Django, thank you for confirmation. I thought your name was Stephen. I had seen a post from you. But glad to have you with us. Renee Cruz wants to be a paleontologist, Daryl.
Okay.
She says it's shaped like a brontosaurus.
She's talking about that coronal hole that's been on the sun. I was trying to make the point in chat, folks. Unless we had a special, the images you're seeing coming from the Solar Dynamics Observatory out in space, if I remember correctly, and they're looking at the sun with a very particular wavelength filter. And if you just looked at the sun with a white light filter, you would never see that so-called black crack.
Right.
It's called a coronal hole.
Coronal holes are magical places because, as you know, Daryl, the solar wind is free protons and electrons that are streaming off the sun's surface. Now, what that means is since they're particles of mass that have mass, the sun is losing lots and lots of mass every second, but not enough to make a difference over some billions of years. But that area where there's a coronal hole, the solar flux, or the speed of that solar wind heading off the sun, is more than twice as fast as normal. Now that's because there's a relatively low impact of the local magnetic fields, and so the corona loops and streamers are always pulling and tugging with their magnetic fields on charged particles, causing them to slow down and to speed up and to be twisted and swirling. Something moving in a swirling path is going to move slower than something moving in a straight path in general. So what we look at here is the same thing happening at the sun. So frankly, when we look at these coronal holes, we're looking at areas where massive amounts of solar flux can reach us much quicker, more than twice as fast as an area that doesn't have a coronal hole. It's not an area of quietude. It's an area of intense bombardment of our poles. And if you have a flare that goes off and comes off in that region, it stands a chance of being unimpeded, making its way here. And some of you in areas that have never seen auroras saw auroras a couple weeks ago because of some of the coronal hole outbreaks. Okay, we're good there. All right.
Izabela's here.
Hey, Izabela.
Hi, Izabela.
You want Darth Vader?
I'll give you Darth Vader, Izabela. You are part of a rebel alliance and a traitor. Take her away.
That's my Vader bottle. It even says so right on the front. Vader bottle. I had this for 25 years. It's the perfect bottle that resonates the voice like Darth Vader. So I've never found anything like it. Just the right thickness of glass. And all it is a stupid vase. And I'm not giving it away to anybody. I also want to announce, and this is in conjunction with Calybos, that we will be looking at starting up a contest for people to win a telescope from us, and of course that'll be courtesy of Calybos. So we're going to tell you the telescope it's going to be and so forth in coming streams and in communications through our community tab. So keep that in mind, all right? And we're also toying with the idea, and I have to talk to Calybos about this, of offering different things as well. We may offer some different things. All right. We're going to head to the Triangulum Galaxy because it's right here and check it out. We should see the fuzzy blob appear in just a moment. There it is. This galaxy, over 2.7 million light years away. If you think about it, you're seeing it as it was 2.7 million years ago. Wow. Isn't that freaky? Very, very freaky. I just think that's amazing. Go ahead, Daryl. I'm sorry.
People say Andromeda Galaxy is the farthest object visible with the naked eye. M33 here is not terribly far from M31.
It's a little farther from us. Yeah.
Anyway, as I was saying, one night many years ago, 1980, I was living in a log cabin way high up in the Rocky Mountains. I had no electricity, and I had a dead black sky. One night I was out looking, and I swear I saw M33 naked eye.
Which is this? You might. This is a fairly bright nucleus, right?
I mean, Messier 31 Andromeda was obvious, big and bright and obvious, and I would swear off a little ways from M31 I saw M33.
Wow. That's pretty cool, actually. That's really cool.
Back before light pollution hit Colorado so bad.
Yes. Okay, we're guiding here, as you can see right there. You can see in our little guide box right there. These numbers mean we're guiding right ascension and declination. So east, west, and north, south. So what we'll do now is, let's make this a 25-second shot. And off it goes. You can see the progress bar down here, this yellow bar down here. When it gets to the end, our first exposure is done, and we're going to make an image sandwich. Multiple images aligned and stacked together to bring out all the data. All right. So this is a histogram. In other words, make it really bright or make it less bright. It's a way of doing some processing. And what we're going to do now is just bring up our live stack. And our first image for Measure 33 is right here. Now, one thing we can do right away is color correct it. If you look at the curves over here, you'll see the red, the green, and the blue curves. This white one is the average curve between them. Ideally, they should all be aligned. So what I do is I align them all, okay? And now, when you align the curves, you'll see that the colors are more correct. And that's just what we see here. These are more of the correct colors. Measure 33's disk has a lot of hot blue young stars in it, and the core is slightly more yellow, right? And as Daryl has often pointed out, we see over here NGC 604. That's actually quite a star forming region in a galaxy 2.7 million light years away. So that's right there. There's another one over here, a famous one, and this galaxy also, you can see all the globular clusters in this galaxy. And I want to give a shout out to Izabela in our chat, because she actually took the time to go through one of our previous shots and show all of the globular clusters that she could find in Measure 33. That was really quite a nice bit of research, Izabela. I just wanted to give you a shout out on that. So there you can see, that's beautiful. Now, if we process this a little bit more, let me get rid of our call-outs on these two nebulae. You'll see there's other things in here as well. In the eagle eyes there, we'll spot some green stuff here. Okay, green stuff here. Okay, and if we move down a little bit, you see a green one down here. Right, a green one right here. Right, there's some green obvious things in here. What is that? Well, this galaxy, like ours, has undergone lots of evolution. A lot of stars have come and gone in this galaxy, and what you're seeing here are the stellar remnants of supernovae that have made it big enough to be seen 2.7 million light years away here on Earth. That looks really pretty, Daryl. Looks like a nice night.
Mm-hmm.
I'm going to process this a little bit to drop the background down to a little more. We can approach our average peak here. If we pass the peak, then we start getting rid of data we want. Like, see this? Watch, see? Now we're losing that little cloudy fringe. We're losing the spiral arms. Now we'll bring them back. You go just to the left of the peak. That's usually the best place to go, right there, right about there. So this is our black line. What's to the left here is just additional brightness of our sky picked up by the camera, as you can see here. The sky has an intrinsic brightness, and so we get rid of it. Nice. This will be a keeper. This is Measure 33. It's a galaxy, the Triangulum Galaxy. So what we do, might as well, we can zoom in a little bit, Daryl. Yeah, look at that. Here's the upper part of the galaxy.
Bring
What's
up
that?
the red more. 604 being red.
Yeah, I think that it's red, but it's saturated because it's so bright in our system. I'm doing a 25-second exposure. I bet you it would be more red if I only did like a 15-second exposure. You know, because we're saturating the red in here. So this might be too long an exposure for the galaxy. Who would have thought that a faint galaxy...
I know. To the left there and to the right.
Yeah.
The stars are quite red. In fact, they're maybe saturated a bit too, but
Yeah. I think they are, like you say.
I don't know. I think I say this every time we go to M33.
Well, you might say that, but it's true every time. It's true every time, and we could pop the red artificially, all right, and we could give it a couple notches without it causing too much damage. There you go. So now you can sort of see there's a little more.
Well, I know. I've probably said this before too. Some of the images I see, they're probably shot with a color wheel, with a filter wheel.
Yeah.
And whether they're using a hydrogen alpha for luminance or whatever, some of them, the red just really pops on the galaxy. And that's got those are guys doing hours-long exposures.
Agreed,
with,
yeah.
Multiple filters.
Yeah. Well, let's have some fun. Let's allow this to come in. Our telescope's performing well, so what I'm going to do is get rid of this whole column. You just go to the full screen and look at this galaxy as it is. Wow. Look at that. Now I've got a big curved screen here, and I've got two screens. I've got the observatory feed on this side of me, and I've got the broadcast software screen on this side, and my camera's on the broadcast software side. I could move it. I could just move it over here. So now I'll be looking in the right direction every time. I could have just done that. I don't know why I didn't do that before. But look at that. That's really something. So it's really just a beautiful galaxy. See the spiral arms here? They're all a little disheveled, and that brings up the nature of this galaxy, right? We have an arm here, 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 one like this, and then you see one like this. It's really kind of a strange galaxy, but those are the spiral arms, Not all of them. I mean, there's some spurs as well down here. But this is the kind of thing that, we notice as astronomers, and it tells us something when you look at these spiral arms. How are they formed? Where they come from? That's a whole nother story. And we don't really understand it that well.
M31 may have done this to M33.
Well, there's that possibility that M33 here might have had a more regimented spiral arm structure, but because, as Daryl's alluding to, Messier 33 and Messier 31 are kind of in the same relative location in the sky and really not far from each other in space.
Well,
Go ahead.
Some say Messier 33 is even a satellite to M31.
Oh, I'd say, yeah. So, Messier 33 being a satellite galaxy. Well, how would we know that? We would know that if we could see and deduce an orbit for a Messier 33. Or we could look at evidence of past orbits by looking for some neutral hydrogen or something that might be streaming behind Messier 33. Find that with a radio telescope or something. And that might give credence to the fact that there might be this long path that has been taken by Messier 33 as it goes on its path. Ginga says there's probably an alien version of Mark streaming the deep sky to its version of the internet in that gorgeous galaxy. Right? We've said that before. We've said that might be someone else looking back at us doing similar things. Look at this supernova remnant. Let's zoom in on this. This is cool. Okay. So you can see that there's a core and there's also this wispy structure around the outside. That's pretty nice.
There's a lot of green in that image.
Yeah.
More down to the lower right of that.
Yeah, right
a little
there.
patch of it right there. And to the left of that, there's some little green ones. And
yeah, we could be looking at more supernovae, huh? Like, might be one in here.
Up 6 or 12 o'clock right now. There's one.
Yeah, right here.
Yeah.
Sorry. Yeah, right there. Right there. Then if we keep going, there's another extended one right up here with a really cool, strange, wispy structure. Another one right there. That's pretty cool. So there's a lot of this stuff going on in these galaxies, guys, you know. Meanwhile, you've got these amazingly prolific star-forming regions here, like NGC 604 right there. Okay, and 604 has these wispy structures that you see circulating around. It's really interesting how that was formed. Who knows, right? And then zoop, we go over to here, and we see another one. And you know, as I look at this, Daryl, I'm noticing that this guy looks like it's almost as big as 604 in extent, if you notice. That's you know, that's pretty big. Excuse me. I coughed on the nebula.
You need to slow down, Mark.
I can't. This is beautiful. Look at it. How could you not talk about? Look at this beautiful. Oh, I want to just cradle that. Come here. I wish I could just capture that. Wouldn't that be something to just capture that and say, I want that. Put it in 3D right in front of you. Study it. Look at it. The core of the galaxy is right here, obviously, and we can see this dark nebulae that's coursing through here. This stuff is really, it's what we see in galaxies. You know, our galaxy has all this stuff. We're seeing it from within our own galaxy, right? So we see this stuff here. What we don't know is what that looks like from there. And then if we could go there and look back, or look through our galaxy there, we might see something really different. There we go. Let's take a trip down to the southern part of this galaxy.
We talked about that neighborhood right there last stream.
This one?
Yeah.
Or this one?
No, the first one you're at.
Okay, yeah.
I said that'd be interesting to be there. It's sort of like being out in the suburbs of the galaxy. You said, well, it'd be so much radiation there from all the stuff going on inside that there probably is not any life there.
I would agree with that. But look at this.
Well, I mean, you said it yourself the first time.
Yeah. Well, that's true, I guess.
My point being, that would just be a really interesting view of the place.
It would. It would be, because that's sort of like an outskirts looking toward the center. It would be actually quite a bright center from that perspective.
Yeah.
Now, here's another supernova remnant. Look at that. And these are all vast star clouds in here. Wow. So when you zoom into a galaxy, okay, let's just go in here. You get in far enough. Now we see lots of noise in here, and that'll all go away with processing. But, okay, when you look and see all these star clouds in here, these are all individual suns, effectively, and the older ones especially. And this galaxy could be teeming with potential life. Could be teeming with life. Wow, that's pretty. Look at that. Oh, I'm astonished by this. This is really pretty tonight. I'm glad I maximized it, because it really is a good galaxy to show like this. Lynn Beats, that's Kyle Lynch. How you doing, brother? Kyle Lynch has been doing some great astronomical discovery with telescopes looking for exoplanets, and he's hopefully been successful with a couple candidates. I don't know when your paper's coming out, Kyle. I'd like to read it, though. Check it out. You've come a long way, man. You know, from saying things in astronomy that were embarrassing to actually doing the right thing, brother. My hat's off to you. Well, it's true. He was off the rails when he first started.
Oh, I know he was.
And that was his passion. So congratulations, man. I'm really, really happy. And it says it's coming out in February. That's good. Yeah, follow Kyle Lynch. Lynn Beats is his YouTube channel. He's got a lot of music up there and game stuff, but once he starts doing more in academia, he's probably going to end up making an entirely separate channel just for that. Hint, hint, you should do that. So, Uberku's with us. Hey, Uberku, how you doing? And he asked, by the way, is the green oxygen? Yeah, that's probably ionized oxygen up there, Kyle. Or Lynn Beats, as you have in your thing here. That green stuff is probably ionized oxygen, yes. The red, of course, ionized hydrogen.
When you see those green areas like that, you could say those are like, maybe the Veil Nebula here on Earth, much bigger, no doubt.
Yeah,
that we're seeing clean over another. I mean, they're supernova remnants, so they're a similar thing as when we see the green in parts of the veil.
Yeah, very true, very true. All right, I'm going to pop in for a moment here because I'm going to save it as we have it here. We've taken 35 frames, so we're going to save 35 frames, and they will appear as the Triangulum Galaxy. Then we'll save it exactly as seen, so this image will show up exactly like you see it for you to take, explore, and enjoy. And it's free. If you want to support our Patreon, we totally need the support. And with a second and then a third site coming up, I would like to have some Patreon people that can support us to continue to bring this to you. This isn't an NPR telethon. Okay, we're serious. Huh?
Oh, I was trying to look up your server to post the link, and it wants a password. It won't let me in. I've never seen that before.
You shouldn't need a password.
Well, it's asking me for one.
All right. Okay.
Let me try again.
Because well, you could go to here, go skytourlive.org. See it right here, skytourlive.org up there. If you you head here, okay, to skytourlive.org, you'll be able to check out what we do. You'll see the telescope currently that we're looking through now, and I'll be out there in January scouting another site for the next installment of SkyTour West. And then, with any luck, I'm going to have SkyTour East back up and running here in just a short time as well. Isabel's asking, what's the black line on the bottom? Where are you talking? Let's let me bring this back to where we want to be. And let's bring back the telescope here. All right. Wow.
Okay, I got in that way. It used to be newest at the top. Now it looks like newest at the bottom.
Oh, that's just your personal sort, the way you sorted things.
Anyway, let me post it.
Yeah. All right, so this is 2.7 million light years away. Let's take a look at one that's just over 2.2 to 2.4 million light years away. And this is going to be up at the server by this name up here, Triangulum Galaxy. Okay, keep in mind, this here is our telescope control. This is our images of the telescopes live, telescope computer. That right there, when you see this right here, it says Triangulum Galaxy, that right there. Okay, that is the actual object that it's going to be saved as on the database when you go look. And when you go to here, you go down to just the gray panel just below the entry and introduction intro area, and you will see the take me to cool pictures indicator. It'll take you right to the server. It's free to get in and check it out. Okay. AstroLin, this is an F2 system. And it's actually the only hyper-starred mead on planet Earth. We have the prototype, and it's really quite, it's performing quite well. So, there is no other hyperstar mead on Earth. I can actually say that. That's weird, isn't it? But it was the only one that they ever did. We asked them to do it. So it's pretty cool.
I have been admiring a scope lately. It's a Sky Watcher. It's a Maxitov Newtonian, 190 millimeters aperture.
Yep.
It's a f5.3. That thing takes some really neat pictures.
Yeah, and it'll give you excellent images too.
1,000 millimeter focal length, if I remember correctly.
Yeah. Astrolin says, "Oh wow, that's neato. I plan on getting a Raza for the Celestron." Yeah, you know what? I looked at Rasas as well. And with a Rasa, you're stuck with a Rasa, which is okay if that's what you want. But this telescope is at f2. But I have the old secondary assembly mirror, and I could take the Hyperstar off and have the old secondary put on in collimation, perfect collimation, in less than 5 minutes. So if I was present there, I could change the telescope over. So that's what's cool about this approach. But I did want a wide field f2 system out under the unbelievable sky we have out here. It's a Bortle 3 sky, and for those that know the ratings, Bortle 3 is actually pretty dark. Okay. Hey, Vincent's Virtues. He says, yes, that's Triangulum. This is the Mesher 33 Triangulum Galaxy, and it's available just like this for free up on our server right now. It's probably up there already. So we're done with this object, so we're going to get out of it and go back to our other enhanced view here, just to kind of show what we're seeing here. Here we go. So that's how it looks with your eye in a small to moderate telescope, perhaps. All right, so let's go back here. This is our planetarium view, and we are here up at Triangulum. And we're going to go now, because we're here, we're going to go right to the Andromeda Galaxy. We started at Jupiter, and then we're going to go to the Triangulum Galaxy we did, and then we're going to go to Andromeda now. Let's check it out. After that, we're probably going to drop down to the Pleiades and check out the beautiful reflection nebula surrounding the Pleiades. And there's the Andromeda Galaxy. Now, this is actually where I want to be. This is, we're going to focus on the upper left part of the galaxy, and then what we'll do is we'll go down and focus on the lower right part. So right now, putting the nucleus here, we're going to get all this stuff you can't see. Then when we put the nucleus up here, we're going to get the stuff you can't see down here. All right. So let me just make sure that we're going to be guiding here soon. Here we go. I'll move this over a little more. All right. Here we are. All right. So we're looking here. We're getting our numbers. And off it goes. All right. So now we're guiding. We could do this. And with our telescope, at f2 with our aperture, you don't really need to do more than 25 seconds. And besides, we're showcasing this to the world, to everybody who's watching from all over the world right now. And thank you all for doing so. And as we do that, I want to make sure that everybody understands that this is live. It's happening live as we speak. You're seeing the universe live in real time. That's what we do. I'm going to clear this last one here, and I'm going to drop off our histogram brightness over here. And now we'll see the first shot here. There it is. And we're going to very quickly drop this out as well. Let me first color correct. And also color correct the curves just a little bit. Remember what I said? Pull right up to just to the left of the peak of the color corrected curve, so the RGB curves are all lined up to each other. All right.
We actually have two Vincents in the room at the same time.
Oh, cool. We have Vince Giglio, and we have Vincent's Virtues. Hi, Vince Giglio. How you doing? He says, too bad the occultation wasn't as good as predicted. Well, in America, it only passed through the lower part of Florida. And we are expecting comets. That's another thing, too. Daryl, you mentioned a comet to me. I know there's one we couldn't get at, but isn't there another one we could look for soon?
I mentioned Pons Brooks recently. It's the one that's been blowing all the stuff off of it and had like devil's horns and stuff. It passed Vega the other night, and I don't know if it's still located where we can see it. Vega's probably getting pretty far in the west now.
It probably is, yeah.
Give me a second, I'll look it up.
All right.
Comet 62P Sushinshan
Sushi?
is in Leo. Okay, here's Pons Brooks. Still in Lyra.
That's problematic for us right now, that's for sure.
Well, let me look at the sky map real quick.
Astrolyn says, I was able to time lapse, I think, quite a portion of Betelgeuse streaming. I think that's possible. And Astrolyn, you're Lynn Beats, right? I'm assuming you're still Lynn Beats, but just different ID.
Yes, the comet's quite low.
Yeah, okay. Hey, look who's here. Petita, how are you? Petita, nice to see you. Okay, this is the upper part of the Andromeda Galaxy. Let's, since we're all matched up here and we're just catching exposures, let's go to our full screen here. We're going to just dump this now again. And on the right side, you can see Messier 110, which is a satellite galaxy of the Andromeda Galaxy. Yeah, I knew it was you, Lynn, or Kyle. All right. Now, notice this galaxy. Usually elliptical galaxies, I've said this before, elliptical galaxies are usually kind of featureless. But this one is not featureless. If you look really carefully, you can see in here, you can actually see that there is strange detail. You can see there's some linear looking detail, circular detail. Now, what happens with elliptical galaxies is usually they don't have any gas in them, and they don't have any dark material anymore. If you look at the Andromeda Galaxy here, you can see tons of of these spiral arms structures in here. They're right here. You can see them. Look at this dark dust in here. Countless supernovae over the years have created all this dark dust that we see here. So clearly, something similar must have happened here, but why don't we see the same amounts of dark dust? It's because these galaxies are either an evolved state of galaxies that used to look like this, or they're precursor galaxies that never got to look like this. It's a tough call. We're not sure. It's a tough call. So, but that's how, that's how these things work. Now, one thing you'll notice right away is that this galaxy, unlike Messier 33, has some interesting features right off the bat. First of all, it goes farther than our extent of our field here can show you. It goes way off the field. But everything here is, you see, like cloudy blue. These are young blue stars, hot blue stars. And here you see a cluster of hot blue stars. Here you see more and more. And every now and then you'll also see a nebula. Now, when we do the lower part of the galaxy, you'll see that we also have a tremendous number of nebulae that are buried. Now, if we zoom in, maybe we can show some of those now. Okay, yeah, right here. See these nebulae right here? Right there. There's a couple there. Yeah.
Michael H. has a question of you.
Okay. So, guys and gals, one thing I remember from when I was a kid, if you have astigmatism, looking through a telescope or binoculars, you'll never perfectly focus the light view. Mark what exit pupil is. It's the point off the end of the eyepiece where the lenses come to, where the rays come to focus. And if you wear glasses and look through binoculars, then you should have no trouble focusing. I have bad astigmatisms in my vision, and I don't have any trouble focusing. What you might have a problem with is you might see rays, strange rays that emanate from your starry objects at times. Depends on what you're looking at. Daryl, you can weigh in on that too if you like.
I used to have 20/15 vision. I had eyes like a hawk. And then I got old and I developed astigmatism. Both eyes have been operated on for implants, and they're still astigmatic. If I look at the moon or bright objects like Venus, naked eye now, stars and Venus, they're big squiggles. And if I look at the moon, I see like 3 moons right next to each other overlapping in one eye, and just a big squiggle in the other eye. Interestingly, though, looking through the eyepiece, I can focus and get it down to where I see it quite well without using glasses.
That's interesting. That's actually really interesting.
Exit pupil is one of those things. I won't bore you with the details, but it's a good thing to try to match the exit pupil of the eyepiece to the diameter of your dilated iris. And maximum dilation when you're young is about 7 millimeters, a little over 1/4 of an inch. And when you get older, your maximum only dilates to about 5 millimeters. So 7 millimeters is ideal for younger eyes. But if you can get a 5 millimeter diameter exit pupil for older eyes, that's pretty good. That's specifically for buying binoculars, but the same thing works in telescope eyepieces.
Yeah. So, folks, as you can see here in the Andromeda Galaxy, we're catching lots of cool detail. And for those wondering, I'm on the tail end of a cold. So that's why I'm coughing a little and so forth. I'm trying to mute when I do. But But when I mute and cough, it looks like this. You know, so either way, it kind of looks odd. But if you look really carefully, you can see the nebulae. Like we see this beautiful one right here. See that?
See, we have 3 Michaels at least in the chat right now.
Michael Hedrick, Michael Galea, and who else?
Michael McCall.
Oh, Michael McCall. Hey, how you doing? I didn't see you come in there, Michael McCall. ARP 273. Daryl, look that up, will you, and let us know what that is?
I will.
Here's another thing, too, I want to show you guys right now. Within the Andromeda Galaxy view we're looking at. If you look, you can see inside this region of the nucleus. See this? There's a spot right here. Look at that. See that thing right inside? That looks like a reflection nebula. Now, reflection nebulae are usually associated with dark nebulae, and here's a dark nebula right here. And it looks like a reflection nebula bordering it. I will say this. The last camera we had on this system, this detail was not available to us. It was gone, not visible. But this camera it's a tighter field of view. Okay, so we're seeing more, less sky, but with more pixels to capture it with. So we see more detail, and that's an example of how we can do it.
ARP 273 is pretty interesting. It's in Andromeda, a little farther out from Pegasus than M31 is. It's almost back in Triangulum. When we're done with M31, we'll give ARP 273 a try.
All right, we do take requests, as you can see. So we'll check it out.
It's an interacting pair of galaxies.
Oh, we'll check it out, especially then. All right, here's what I'm going to do. I'm going to, we're at 26 frames here. I'm going to stop this here. I'm going to save it. I'm going to name it first. So this is going to be M31 Andromeda Galaxy. And it'll appear like that on our server that is free for you to go check out. Again, how do you get there? Go here. Go to skytourlive.org right there. And when you go to skytourlive.org, you scroll down just a little bit and go to the panel that's a dark gray panel just below the entry. That's our portal site. And it'll take you to our database portal where you can explore the folders full of these images. All right. So saving as seen. I'm actually going to do it again now because we wanted to make this 28th shot, and then we'll save it just as exactly as seen. Lots of detail in here. Okay, now we're going to do the exact opposite of this. All right, and we'll go to our view here.
You know, you took the lower right shot last stream we had. I don't remember if you saved them or not.
Oh, of course. But I like, I'd like to do, depending on the night's clarity and stuff, I like to try and do mosaics all on the same night kind of a thing. Because, I mean, with our fast system, we can do that. You know, let me just bring the telescope in now. Okay.
Heck, I've seen people add data months and years apart.
Oh, of course. Yeah. That's true. All right, so here's what we're going to do. I'm going to drop this down.
Just data on a hard drive. It's not like a photograph.
Yes. Okay, now we're going to go to the west. There we go. Now, what this will become is a mosaic. We're going to create images of the Andromeda Galaxy, and they're going to be it's going to be a mosaic of the galaxy. So now we're going to get the lower right portion, which I think is more interesting than the upper left, to be honest with you. But if you saw those nebulae in there, we're actually making some really great strides. Now here, right there, you see another little elliptical galaxy. That's called Messier 32. This is Messier 31, Messier 32, and that one that we just lowered ourselves out of, that's Messier 110. So it's 3 Messier objects in one field of view. All right, we are guiding now, going to town, so we're going to take our system and we're going to come back and do 25 seconds again. Okay, so it's going to be 25,000 milliseconds. And it will automatically go to 25 seconds. And meanwhile, we'll go into our stack again. It'll be bright because it's showing everything that's in this field. All right, and get rid of this brightness there. Now we're down to that. And we'll clear this because we have 5 seconds left on the first image from the lower right of the galaxy. And that's coming up right now. There it is. And by the way, every image is going to be perfect because we're using a special full width half maximum filter, which means if the star images get too bloated or too big, that image is ignored. So you'll see the images that we've captured and you'll see the images ignored. Okay, and tonight there hasn't been any of that. Usually we get that happening. As you can see, I can actually drop our full width half maximum requirement down. I'll put it at just about 6. So that dashed line, anything above that means there's going to be a little bit of oblate stars. I don't want that. And neither do you. Alright, so now we'll go back to our histogram. Let's do a color correction. Okay, look at those curves all nice and lined up. We got this all set up. Alright, now let's get rid of this. And let's also get rid of this. And go back to our beautiful big shot here. That's interesting.
Look, you zoomed in.
I am. I gotta pull out. I'm at 52%. So I'll go back to 25%. There you see. That's really pretty. So we capture Messier 110 right here. We've got Messier 32 right here. And then we have the lower part of the galaxy right here. I could have actually dropped this lower. I think I was zoomed in when I moved and I forgot to zoom out.
What I was thinking.
Yeah.
So now you're still missing a fair bit to the lower right.
Yeah. So what I'm going to do is I'm going to cancel this without saving it. Okay. And we'll just quickly move it where it belongs and restart. There we go. Okay. And let's bring back my controls. There we go. Alrighty. So now we can drop it down. Messier 110 goes away. I forgot that I had zoomed in. Vince Giglio. Hey, sorry about that. Yeah, I know I kind of went bright there for a minute. And if you had it on your big screen, I apologize. You know, a lot of people will put this up on their big giant televisions. Yeah, it's really cool. Seeing Andromeda Galaxy fill your screen, you know. Okay, here we go. This is pretty good right here. I'm going to drop down just a tad more, just to eke out that little extra bit that's down here. So now we're going to have that OB association, that bright set of stars right about here. Okay, here we go. We're getting ready to do guiding. Here it comes. There we go, right there. All right, so now we're guiding away here. Let's do another 25-second shot, so 25,000 milliseconds. Okay, and off we go. All right. Our yellow progress bar is moving across the screen here. So I'm glad you guys like this. Now I'm going to go in here to the stack. And I just blinded Vince Sciglio again. Sorry about that. There we go. Alright, so we're going to get rid of this here. That is, sort of shows you what's there. Now check this out. Watch this. We're going to color correct this, which doesn't need too much color correction, but you can see it. It looks beautiful now. And then we'll see where it wants to go. What it does is it likes to lighten it up a little bit. I prefer to come just to the leading edge of this curve. And I let that one ride there. This is the mid-level. So if you pull it down, then the soft stuff goes away. If you bring it up, then you get a lot of noise. So it's a blend. Okay, but if you do that, okay, look how blue this is. See this blue arc? That's famous in the Andromeda Galaxy. That's a beautiful selection of very, very hot young stars. And they're actually stars that kind of render this region of Andromeda, or would render it, pretty much lifeless. Because most of those stars are giving off their energy in the ultraviolet, which for carbon-based life is kind of problematic, because that causes mutations.
You're no fun.
I know, right? You're no fun anymore, Monty Python. There we go. Okay. So there. Now this is looking really pretty. You got a monkey with this here a little more. Here we go. Okay, and then we can be done with that. Okay, let's get rid of this and do a full screen. Hoo-wee.
Interesting little dark lane
This
down
one?
in the lower part of all that. No, to the right. That's the lower right of that.
Oh, down here?
Right there.
That's true. Well, we have another dark lane right here. See that?
Yeah.
Wow. Hey, Sam S. Sam S says, is that where mutated Godzilla comes from? Well, to be honest, that was the Japanese doing a morality thing of nuclear testing and nuclear radiation. And you can understand them doing that. You know, their country was whacked by the U.S. in the only ever nuclear attack undertaken by a superpower against another. That was us that did it, so not a proud moment. Look at that.
There's a new Godzilla movie out.
Godzilla.
Godzilla
Murphy's here.
-1. Everything I've
Really?
read, they say it's a really good movie.
Nice.
Low budget, too.
Anahata 77 is Bonnie, and she is with us. Hi, Bonnie.
Bonnie.
I did not get rid of the heart that you see in the chat. I'm sorry. I should have done that. I didn't do it. It's something you have to do after you get going, and I didn't do it. My mistake.
Sam Mess saw the new Godzilla, so that's great.
Really? Wow.
Godzilla's one of those things, they should leave it to the Japanese. They know what they're doing. There have been several U.S. or Western productions and iterations of Godzilla, and I think they all missed the mark.
No. Yeah. Well, that's too bad. That's too bad. Okay, we are up to 12 stacked images here.
How many did you do on the upper one?
27 or so.
Okay.
I want to get a close to an even number of
Right.
them, but and then we're gonna go try that ARP object and see if we can see it.
Okay.
Now again, it's an F2 system. I don't know. Well, we can actually bring up our planetarium while these are coming in and look for the ARP object. Actually, let's see if we can bring up our deep sky objects here. We have an ARP catalog right here, and that's probably going to have it in it. We also have Lynn's Bright Nebula, Lynn's Dark Nebula. Vandenberg objects are good. Sharpless are always helpful, and the Barnard objects are cool.
Michael McCullough has some information you may find relevant.
All right.
ARP 273 is 300 million light years away.
Wow, it's going to be a small object then.
Yeah.
Alice Pooper's with us. Michael, thank you for that sharp cap info. I routinely upgrade the software in the observatory, and the planetary live stacking tool is going to be very helpful. So thank you. Very nice. All right. ARP 231, right?
I'm sorry.
ARP 231?
273.
Is that what it was? 273?
I believe.
Okay.
Alice, we had a meteor come in over town here some years ago. It came in very hot, very fast, very low, and it had a terminal detonation just a couple of miles south of me. Neighbor said it knocked him out of bed, and I slept right through it. I never heard a thing.
Wow.
They think it landed out east of town somewhere. They have it on video.
Well, that's pretty cool. Oh, look, the galaxy's actually... This red represents our field of view, guys. So, you can see that in this square, okay, compared to this square here, this is roughly our view here. These galaxies will take up about this much space, so we can try it, see what we get.
Sure.
They're only 12 and 13 magnitude, so they're going to be pretty faint. Yeah, Michael, thank you. That was Michael McCall. That was excellent. I've been meaning to upgrade and get this up to snuff. Which one do? Let's see, what version of Sharp Cap do I actually have right now? Let's see now. 4.0.95450. Okay, so good. Look at this. This is just beautiful. Let's start to zoom in now, because now the fun begins. We can actually see some really interesting stuff in here. Okay, we move through. Here is that really, really dense region, this dense knot of O and B stars, like an OB association as they're usually called. But my favorite spot in the entire Andromeda Galaxy, believe it or not, is this little guy right here, which I'm going to point out to you right now. Check out this beautiful wispy nebula inside that red box. Isn't that cool? It's got this beautiful wisps to it, and it's really nice. I just love that little nebula. It's my favorite spot in the entire galaxy. I mean, I do like the OB association. Don't get me wrong. Don't get me wrong, but this little guy right here, has this beautiful look to it, and I love this fan. This reminds me of Hubble's Variable Nebula, which is technically up right now almost, but we can't really see it too well because we have a limited eastern horizon with the building, and that's because in that direction, about 75 miles away, is Phoenix. And even though we're far enough from Phoenix, there's a glow that goes up in the air depending on the amount of water vapor that's in the air. And that, unfortunately, will cause us to not be able to take images of really faint objects. Rocket City's with us. How you doing, man? Thank you for coming. We shot the We shot the Triangulum Galaxy and the upper part of Andromeda. Now we're doing the lower part of Andromeda. So you kind of missed a few things, but yeah, you're all right, man. So besides my favorite little nebula in the Andromeda Galaxy and this gorgeous OB association, one thing I haven't seen in the Andromeda Galaxy, like we saw in Messier 33, supernova remnants. I've not seen any in the Andromeda Galaxy. And where they'd be is tied in with these OB stars, because some of these undoubtedly have gone supernova. It's just interesting. Another beautiful nebula right here. See that nebula right here? Wow. Now, once we're done with this, we'll put it together into a finished Andromeda Galaxy that you can check out too. We'll make that available to everybody. Rocket City Astro is doing his own stuff right now. He's actually doing Barnard 22.
Gonna have to look that one up.
Oh, I'm doing it right now. It's a double star. It's not a Barnard object? No. Alright, this is a mistaken identity. He's not doing that. Let's do it this way. There we go. Oh, there we go. It's the dark. Okay, it's this Taurus Dark Cloud Nebula. Remember he did this one?
I don't recall offhand.
Yeah.
I see cool pictures of it. Oh,
Yeah, we did it. And it'd be a good target tonight. We'll try ARP after this. It's right below the Pleiades. Hey guys, follow Calybos lead and do click the like button and subscribe if you haven't, because then you can see the coolest images, learn from an astronomer. That's me and Daryl, and we'll both be able to share with you what you're seeing with the night sky. Okay, we're done with this guy, so let's bring everything back. Okay, let's bring back my telescope panel here. All right. And we're going to save it under Andromeda Galaxy again. It's almost just overhead, so this is going to be a really pretty image. It's about the best it can get. Okay. All right, so that said, let's go back into our search mode with our nice low light, low camera light search mode. Okay, now we're gonna look for that ARP character. Okay. Now this might be small, but we're going to try it, okay? So here we go. I don't even know if they'll actually be in the view. I mean, I don't know if they'll actually be visible in our low light shot because they're so faint. We pop them out. Let's maximize our values here. I can't tell. All right, let's drop our sensitivity back down. All right, and now let's just give it a shot and see what we got. We'll start going.
Izabela has a question of you.
All right, Izabela, 1 second. Let's go to there, clear that. Where in which catalog are the globular clusters? They're in the NGC catalog, they're in the IC catalog, they're in the Measure catalog, they're in a variety of catalogs. Oh, there they are, right there. Okay, so that's where they are, so that's good. Hold on,
My
Izabela.
imagination, or is that star at upper right, is it green? Not star, but you know what I mean.
That right there?
Yeah.
Yeah, that's your imagination. There are no green stars.
Well, I know that.
Okay, let's go back to 1 second here. We're going to move these up into the center. All right, so they're right there. And okay. Then we'll head west with them a little bit. It's funny, I actually see them now. Okay, so they're gonna be just about here. All right, let's get our search running. I'm always in the mood to try new things, so let's do it. 25 seconds. Go. All right. And then we'll do our stack. So we move these up and over. Let's see if we can get any structure out of it. I can see that there's some really interesting structure there. Excuse me.
I think you might need some focal length for this one.
Oh, for sure. Look at that, right in the center. Okay. Well, let's see if we can pull out some detail in it. I mean, I can see the structure here. Looks like two interacting galaxies right here.
Mm-hmm.
Okay, let's see if we can soften the noise. Let's go into enhancement. Let's see if the unsharp mask will help us. Yeah, we got a little more view there. At the same time, let's add a bilateral filter. The bilateral filter will soften the noise and help differentiate detail from noise.
Izabela, we're looking at ARP-273, ARP-273. It's a pair of colliding galaxies. The picture I saw was rather reminiscent of the antennae.
Yeah.
Different, but sort of similar, you know.
Look at that. You can actually see a nice shape in there forming up already. And let's zoom in a little more. Wow, look at that. You can actually see this interacting tendrils moving into the galaxy. I think this might be a star, and this might be the nucleus of the other galaxy. I have to be careful about that. Maybe not. They might be... not sure what they are. Let's see if we get any hints from this. Okay, yeah, so one's a star. Okay. Well, that's what it's supposed to look like. Okay.
Yes.
It's upside down here.
Where?
Well, it's upside down. Okay, if you look in here. Okay, if we put in our image here, if we zoom out a little bit, right, get our red square. Notice it's upside down. Okay. In other words, our telescope is backwards, so it's looking up, but it's basically its head up in the air, so it's upside down compared to the telescope, the view. So in this image, okay, we're seeing it from the right side up position, so we see the big galaxy down here and a small one up here. Okay. Yeah. Actually, here's the big galaxy now here, and here's the small one here.
Right.
So color's coming out good now.
The images I've looked at show it like you do. The one to the lower left and the big disturbed spiral to the upper right.
Yeah, these guys have passed through each other once already, at least. Not really sure. I have to look at the research on them. That's something else, though. Let's see what else is here. I'm going to just pop this up here by looking at that histogram over there. So you can see the extent of the galaxy. This mode is just to show detail that's hidden, which means detail that we can actually pull out later. But you can see right there that there's a lot of rich detail in that galaxy, even though it's small. This object would be completely invisible to the previous camera. Not a whole lot of detail. We are cramming a lot of pixels into a small amount of space, and the other camera had larger pixels. The next telescope we get will be almost perfectly tuned for that camera. This telescope was never perfectly tuned for the camera we used to have, which was the ZWO 294 MC Pro. What we're using now is the 183 MC Pro. And so we have more than 5,000 pixels across and 3,800, 3,500. Let's find out. Let me see what it says. It's 5,500 by 3,600. Basically. So that's we're cramming that many pixels across and down. So the previous camera was 3,800 across and 2,200 down. That's a massive difference. But this camera, what it does is it shrinks the size of the field that we can see, all right, because the sensor is smaller and tighter, but puts more pixels in there so that we see a smaller version of the sky. So in other words, we're zoomed in a little, and then we're cramming more pixels in there to capture subtle detail like these really cool loops that you're seeing right in here now. That was a good suggestion for R232. Thank you there, Michael McCall.
273.
273, thank you. Very good. That's an excellent call.
Wiki says what you did, that the smaller galaxy has passed through the upper galaxy. Upper galaxy mass is about 5 times as much as the smaller one. And the smaller one went right through it.
Very cool.
Yeah, in your image you can see the big dark curved patch on the left side of the upper galaxy. Other images, it looks almost like a big mouth, like a clown mouth or something that the smaller galaxy came out of.
Oh.
It's the upper galaxy has found a great big loop out on its lower side, and it's showing up there.
Funny Photon, thank you for the reference to the ARVO catalog of globular clusters. Bright globular clusters. Izabela, take note of that and look it up. Maybe that's something you can use. Okay. Okay, we've done 18. We'll go to 20 on this. And then we'll check out the Pleiades like I promised. And then we'll check out what Michael Galea is shooting right now.
Should remember this one when you get the next scope going.
Oh yeah, this is a good one for the next scope.
Or could you excuse me a moment, please?
Sure.
I bet.
I think. Hey, who was shooting the Taurus cloud? Was it Rocket City? I think it was Rocket City that was shooting that, not Michael Galea. Yeah, I think that's... Rocket City was doing that. Sorry for the confusion. Funny Photon says, do you ever do sessions with images and then show 3D animation or simulations of the object? Yeah, actually I do. We use our simulation software, and we've done that actually. We teach people how to use some online stuff as well, and I find that it's actually very, very useful. Sorry, that was my microphone. I find it's very useful to teach people how to do this because it's a lot of fun. And then they can actually spend hours whiling away their time, which I think is kind of fun. Calybos, you don't do spam. What are you talking about? I think it's important to remind people to support us. Funny, as far as the sessions we did with that, I have to go back and look. We've got over 400 sessions online. So, I can't remember specifically which ones. Sometimes we do cloudy night streams, and we'll do that. We've also done the LROC, the Lunar Reconnaissance Orbiter camera, quick map, and showed people how to use that to navigate the moon and do scientific data, study analysis, grab 3D model stuff, then 3D print, and so forth, because that supports it. Although it's not as good as the stuff that we use from the USGS, but it is really cool to do. Okay, we're at 25, so we're going to save this. And this we're going to call what it is. This is ARP. I'm going to get it wrong again. 273? Is that right? Let me actually go and look. Let's go look here. Yeah, 273. Okay, you actually got it right. Yay. All right, it's ARP 273. It'll be interesting to see how this comes out. Kind of cool. All right. Okay, here we go. All right, now we're zoomed way in. I'm going to zoom back out here. All right. Now, let's take ourselves out of this region of the sky for a brief time. And oh, the Silver Sliver Galaxy, that's really pretty. Oh, we got to do that. Silver Sliver's pretty. That's really pretty. You got to see this. Got to see this. Okay, let's check that out. Sorry, I was on my way to Pleiades when I got stopped by a sliver. A silver sliver. I don't think we got it right now. I'm going to have to check it out. Let's do just a 10-second shot here. And see if it shows up. I don't think it's here. Oh, there
What
it
are you
is.
looking for? Ah,
Silver Sliver. Silver Sliver.
all right.
I couldn't see it. And now once we see this, now that we know it's there, we come back, we'll probably see it standing straight out. Like, yeah, there it is. All right, let's bring this up.
Silver Sliver.
That's right.
Go by another name.
Oh, undoubtedly. Let me go find it. Let me just center it up first. We're going to center it up. And here it is.
Just C891.
Yeah. That sounds familiar. Okay.
Also in Andromeda.
Yeah. That's true.
Sorry, I'm catching up here. I thought you were going to Pleiades when I left.
I know, and then I went down and said, hey, look, the Silver Sliver. And I said, I'm going there. So I'm doing that. And maybe by the time we're done, we might... I don't think so, though. It's gonna... I don't think we'll be able to get to the Andromeda Galaxy. I'm sorry, the Orion Nebula. I don't think it'll be there. Not until a little later, but we can try. All right, first of all, let's do 25 seconds here again.
Well, it's a cool galaxy.
It is.
Reminds me of 4565 in Cold
Yes,
Barnard.
yes. That's your favorite, one of your favorites.
The Needle Galaxy.
Yeah, Silver Needle or the Needle Galaxy. Yeah, that's right. All right, so we're cleared. 5 seconds. 2 seconds. 1 second. And if the frame is acceptable, and it is, there it is. Look at that. Beautiful. What a beautiful galaxy. Let's
Build it up a little bit. Zoom
Yeah.
in on it.
heck yeah.
Photos I see, there's tons of detail along that central dark band.
Yeah.
Dark lane, whatever you want to call it.
Yeah.
I mean, it's smaller, I think, farther away than 4565, but it is very similar.
Mm-hmm.
And
I think it's more of a central split than 4565 is, in fact. They got this bisecting line. This actually is the dust. You know, the galaxies are kind of, disc shaped, right? And then at the edge of that disc, that's where the dust tends to congregate. So when you see the dust in the Andromeda Galaxy, the dust in Measure 33, the Triangulum Galaxy, it's all along that central plane. And so from the edge, if you're looking at it edge on, like this, then the dust is going to be concentrated all along the edges of the galaxy all the way around. And you can't see the far side, but you can see the near side. And this is what we're seeing.
when we look at 4565, we see the nucleus peeking out a little bit more than we do
Yes.
on this one. This one, it's more close to the center of the dark band.
Yeah, that's what I just said. It's more an even split. But it's It's not perfect though. As you look at it, if we get really close, right, you'll notice that it's still not perfect, but really darn close. That's gorgeous.
There's actually a whole lot going on inside that dark lane.
We're
That
gonna let it build up a little too. Yeah.
bright areas, dark areas. So I see a couple in the lower part of the disk, lower right.
Mm-hmm.
There's a lot of stuff going on in that dark lane.
Yeah. Calybos says we may be giving away a C-Star scope at some point once we get enough subs. You know, we get support in Patreon, and SkyTour Livestream will assist in getting some of these higher end pieces of equipment to give away.
Astro Backyard did a good video on the Sea Star. It's amazing what that thing will do.
Yeah.
And that thing, it just has a 50 millimeter aperture, which is a hair under 2 inches, but
Yeah, it's small.
still, it was really interesting, the detail it managed to capture.
Yeah, Cosmic Ray sent an image showing a C-Star of the Orion Nebula with the Running Man. It was good, you know, but what it lacks is resolution, right? But it still is a beautiful image. It's beautiful for people who want to just take some beautiful shots and they don't know how to do it. Let the camera do the work for you.
Funny. How did William Herschel find this? With his eyeball. Okay, this was before cameras of any kind. He found it with his eye.
And with speculum metal.
And a whole lot of patience. That's cool.
Yeah, nice little find. Izabela asks, very thin in relation to their diameters. I think that's where she's going with that. Do they get thinner as they become older? Not necessarily. And so it depends how much mass the galaxy has in it. It's not like stars are flung out to make it thinner and wider and bigger. So the diameter of a galaxy doesn't really seem to change. So it's just that when they form with this many stars, this is what we get. And some galaxies are actually very distorted and not shaped like anything you'd recognize. Some galaxies are just these ellipticals. Some have a bar across the middle with spiral arms off the end of these bars. Our galaxy is one of those. So
if
there's
you
a lot
could
of,
look at this, if you could use your little tool and draw a line across left or right, just below the center.
Yeah.
Pretend that line would be the southern horizon on Earth, and zoom in a little bit, and you would pretty much be seeing our Milky Way galaxy.
Yeah, let's do that. So let's do this.
Yeah, about like that.
Okay, so I know where he's going with this. And then we could just... okay, I'm not able to zoom while I'm doing this. So I can't do that yet. What I have to do is this first. I gotta zoom in first.
Yep.
Okay,
And
do
then-
that. And now,
Yeah.
if you could just imagine
Or
As Daryl was
just if
saying.
you can pull it down just a little bit farther.
Well, then
the,
they could just be done with it, yeah.
Yeah,
You're right.
bottom edge to the cutoff.
See, so here is
Right
the
about there, yeah.
here's the northern Milky Way, with the southern Milky Way. The Sagittarius would be here from our view. That's kind of a rough idea. That's actually a cool idea.
And the dark lane would be like the Great Rift in our Milky Way.
That's right. That's right.
Okay, you can center it back up if you want.
Yeah, I'm just gonna back us out. We'll go to about 20 with this guy. And this is the silver something. Silver, not the silver streak, is it?
Sliver.
Silver sliver. People in their names.
NDC 891.
Yeah. But silver sliver actually is more descriptive. All right. All right. One more exposure, and then we'll move on to the Pleiades as promised.
That's pretty.
Oh, it's really nice. Let's see if we can get a little more detail out of it. Look at the convolutions inside this dark central part. There's a lot of detail in here. Look at this, guys.
Yeah.
Look at all the knotty detail in here. K-N-O-T-T-Y, knotty.
That's what I was talking about earlier.
Yeah.
You see little bumps and zigzags, especially in the southern part, the lower part,
Yeah,
and
look at all that, yeah.
bright spots in it, and those zigzags and things.
Yeah.
A lot going on in there.
Wow. Yeah, that's really pretty. Okay. Izabela, you made a comment about understanding something and trying to see where that comment was.
Says message retracted.
Oh. Maybe that's what it was. Okay. No wonder I couldn't find it. Alright, one more save, and one more save exactly as seen.
That's nice.
It is. Nicely done. Okay. Now, onto the Pleiades as promised. Unless I see something else come up.
Oh, she was complaining.
She was complaining?
Well, she says,
Well,
not important.
she doesn't complain. She doesn't complain. Alright, here we go. Okay, now. Let's back out of here. Our amazing planetarium program. And head on down to the Pleiades. Let's just back out here. I gotta... There we go. Merope Nebula is really pretty. Okay, so off we go to the Pleiades. Still high in the sky. You won't miss seeing these stars come in because these are bright. Here they are. Can't miss this constellation. You can even see the nebula around us already. That's Alcyone. And we're going to just drop it down into the view. over 100 stars in the Pleiades, and all people know is the 7 sisters.
Over 1,000.
Over 1,000, is it?
Yep.
We're about 400 light years away, and we're only seeing the surface. Now this cluster as a whole is moving together through space. A fairly young cluster, and what it's doing is, as it's passing through this particular area of the galaxy, it's passing through dust, and the dust is very good at scattering the blue light from these stars that is given off the shorter wavelength, higher frequency light is blue, longer is red, and so it scatters blue very efficiently. This dust does. That's why we see a lot of blue nebulae in galaxies and so forth, because stars' light is scattered, and particularly the blue component, by that dust quite well. Alright, so we're guiding now. And let's do just a 22-second shot here. Doesn't take much with this cluster to really overwhelm things. Alright.
Fits the field of view of the new camera well.
It does indeed. We still have, unfortunately, we still have halos. But we get rid of the halos in post-processing. But here comes the Pleiades. I think we might have lost that first one. Let's see if we got... we got a red line. Okay. So it might have been that the wind is blowing enough to ruin the exposure, and as such, it's not. I gotta raise the bar here. So if this one comes in, it'll probably be just a little bit elongated looking.
The wind just pick up.
Yeah, well, as the desert cools at night, the winds pick up. Yeah, see? Look at that, though. That's really pretty. Here's Merope. Here's the Maya Nebula. Look at that sharp little finger right there. That's something else. As you can see, when we zoom out, we can't even catch all of the Pleiades anymore because of the fact that the view is not big enough. Look at this massive dust cloud that is being affected by the starlight. I really like this here, this edge of the Merope Nebula. It's a sharply delineated area, and it's got some knots of brightness in it. See that? That's really something. Kind of like somebody took a paintbrush and just took blue paint and just sort of did a little tiny streak.
Did they used to think that the stars were forming within the dust clouds? Now they say that the cluster is just passing through the dust cloud.
Yeah, that's what I was referring to before. Is that the stars are moving as a group around the galaxy and passing through this dust. But that said, the reason we know that that's not look at satellite coming in. It's probably going to be over here next and over here. The reason we know that these stars are moving separately from the dust is because if we study the motions of the stars versus the motions of the dust, We can see them moving in two different directions.
Am I muted? Am I muted? Oh.
Sorry, I muted to cough there, guys. I'm gonna have to get another bottle of water. No.
Oh, when
I
you
muted
look up,
myself to cough.
when you look up in the direction of Taurus, it's very dusty up there.
Yeah, and after this, we'll take a picture of that Taurus dark cloud, which is really, really cool looking.
Yeah.
It's Barnard 22.
Yep.
And if we come into our planetarium, okay. All right, hold on. I'm just trying to.
Come on. That's in Aries.
What's that?
Oh, nothing.
All right. We're going to go to this next. Check it out. All right, so see we got all these greens. We'll go to 14 exposures here, and then we'll head over to Taurus. Just a few minutes. Look at how the details come in out, guys. See that? Look at that. Detail is gorgeous. Look at the complexity up here in Maya. And the Merope Nebula, the beautiful streaking is just stunning. So let's just change our name here to Measure 45, which is the Pleiades. All right. And we'll save it. Okay, so now we saved already. We're gonna get out of here. Oops.
Michael Hedrick asks, what about the bubble around the solar system that Voyager found keeps out some radiation? Do other stars have this effect? I think it's safe to say other stars have what they would call a heliopause around them, just as our star has one.
Which is where Voyager passed through.
Yeah.
Yep.
That's like when you've crossed the line from the sun's neighborhood out into truly interstellar space, where the solar wind is no longer an issue.
Okay. Let's just move a little bit and go to the dark cloud in Taurus.
Michael McCall says, ever hear of Lynn's Bright Nebula 762, the Drunken Dragon Nebula?
Not by that name, but I'm sure we could very well have imaged it. All right, let's. I think this might be that. Well, we'll see. I'm going to do just a 12-second shot here.
LBN, Drunken Dragon Nebula, is in Aries, which we're close to.
Yeah, that's what I thought. Okay, we're looking there. Okay, good. All right, we're in good position. I'm going to take us now. We're going to go 35 seconds now.
Interesting object.
Yeah. And we're going to do a 200 gain. Now you might notice, well, why can we, if the camera can go up to 200 gain, and how come we don't, why don't we use it at 200, like 400 gain? Like if it can go up to 400 gain, why don't we use that? The reason is because there's a certain sweet spot with the ZWO cameras where you don't get a ton of noise, and it's, for this camera, it's about 100 gain, but we're looking to do something a little bit more, so we go to 200, and we're kind of pushing that a little bit. Oh, sure, we could go to 400. But see, this is already getting you can see there's a cloud here. And you'll see this is a very dusty region of the universe. Very, very dusty. And as we get more stuff in here, we'll be able to show you that even better. First of all, we're going to color correct. Alright, now we can zoom out a little bit. So this is a central part of that Taurus dust cloud that Rocket City's doing right now. Very nice. Let me take off leave them, take off the unsharp mask right now as well. And notice right away when you look at this image, lots of stars up here, no stars, very few, and then lots of stars again. You can see that this is a big finger of dark nebula that's between us and the stars in the background there, and through little tiny slivers, you can see the stars behind it. This is exactly the type of thing, in fact, exactly the type of place where planets and other stars get formed, is in here. Quite nice. You can see a dark object. This is a dark cloud that's appearing here. If we bring our other histogram up and really push this, you can see a little bit more of what's here. Although that's not as helpful yet because we don't have enough frames. We only have 5 stacked frames. We need more. Rocket City says he's going to need a lot more stacked frames. Well, it turns out that the resolution of your stack, remember what the stack is. You take a picture, take a second picture, align it with the first, stack it on top. So nebula like dark nebula you see here gets a little bit more data punch, if you will, so that if the data gets punched up, you can see more detail. Stack like that and make an image sandwich over time, then you get better appeal. You can see better stuff. Here we have 6 images stacked right there. You can see it. So how many images would we have to stack in order to roughly double our detail level? It really comes down to you basically have to do twice as many exposures to punch that detail level up. So if we take 20 exposures and it looks okay, to get it to look that next level better, we have to get 40 exposures. It's kind of a rough rule of thumb. All right, let's see if we can dig out some more detail here. Oh yeah, there we go. We're getting a little. This one's going to tell the story as we move it over. And pop it down at the high end. Narrow the curves out. Now you can really see the difference between the stars here and the cloud here. See that? It's like you actually have clouds in the sky.
I think a good bit of it's going off the top of the screen. There's a lot happening in there that is just barely registering so far.
I know, I have no choice because the frame is a certain size. Okay, so if we zoom in, we're here. And again, notice that at this point, okay, we are right side up, right? We have to just like tip our heads to the left. Okay, so top of the screen is up here. So if we come in and look here, okay, you can see that there is a lot of stuff going on up here, yes. Maybe what we should do is, we've got 9 images stacked. We're going to do more. Might behoove us to look a little above this too. Unless you have an object you'd like to check out. It's up to you. Okay. Here, see now the clouds are starting to define themselves. It's a really subtle patch.
Whoops. Can you go back to Solarium for a second?
Sure.
As you see here, the dark. Okay, so that oval ring around it is stars. So you got a big dark clump, and then you can see stars around it, and then more dark around the oval of stars.
Yeah, that's see, because you're seeing the cloud here blocking these stars in the background.
Yeah.
So this is between us and those distant stars. Really interesting.
There's a whole nother layer of dark to the outside the field of view. It looks like you could shoot like a pretty big panorama of this, like 3 or 4 across and 3 or 4 high, maybe.
Yeah, I won't do that tonight.
Actually, it's quite an extended object.
It is. But it is an interesting object nonetheless.
And per Isabella's question, this is Barnard 22, right?
Yes, it is. Yep.
Is that a bright star just out of field to the left?
No, that's actually the amplifier glow.
Oh, okay. I thought I was trying to remember what you called that before.
Yeah, no,
Those those look
norm-
like almost like a bright star. I thought you said
yeah,
you
I
did
did.
flat
If you notice down
flat
here,
frames and dark frames and got rid of that.
yeah, down here, I'm over there on the right. I'm subtracting a dark frame, but the dark frame was done at 25 seconds. We're doing 35 seconds now, so there's a little bit more peeking in right now that would be otherwise much less visible. Because I'm doing a longer exposure.
Funny, Photon says your stellarium was not on Barnard 22.
What does that mean? No. No, okay. He's talking about the Taurus Dark Cloud Nebula, which is Barnard 22.
Okay.
I chose to then go to the central part, LDN 1527, which was this central Brighton region in here. So
Okay.
that's well, that's correct, yes. But I wanted to do this. I was on Barnard 22 initially, incidentally, and then I moved to this. So if anything, I could change this name, but I want to kind of do a composite or a mosaic of the upper region here, which will include Barnard 22. So what I'm going to do is I'm going to end up, let me do this. Okay, that's where we are. So the dark cloud is up here, okay, further up here. So I'm going to jump up there and do some of that and leave it at Barnard 22 because that'll be in the frame.
All right.
That's just, my thing.
I have a question. If you can catch the Pleiades now, can you catch California Nebula yet?
Oh yeah. You can. We could catch the crab as well. I'm going to do 20 shots here. Sent you a chat message about that.
Oh, all right, that's you. Whoops.
Okay.
I think you're right.
Okay. Alright, I'm gonna save this here. Save it exactly as seen. Okay. That's 20 shots. Now what we're gonna do is we're going to move this nebula down here and capture what's above it. Alright, so we'll put this star right here down near the bottom. Alright. And then we'll capture the entire region that will include Barnard 22, as mentioned. And then we can mosaic that. And Cosmic Ray can spend 9 hours doing that. Won't that be funny? Okay, that should catch enough of it. Let me just drop us a little bit lower. Okay. We'll be guiding here in just a minute. And the nice thing is I can just start taking pictures right away. And only when the guiding is perfect will it take the image, capture the image. This will be another 35-second set. Alright. On its way.
Looks like a whole lot of dark there.
I know, I saw that. So, in here, this is now moving down. This star is down here, so this cloud continues up out of frame, and we're going to be capturing the top part of it.
Right.
So, that's what we're doing. So we'll clear this now. Okay, and there's our first image in there. And you can see all the many more stars here and the cloud here. And yes, it's a very extensive object, so it's going to take up a lot more space than our view. But just to make them consecutive, we're not jogging them over. Okay, I'm just going up. There's more to the right, yes. But for tonight, we'll do this. Izabela, yes, I'm making a two-panel mosaic. Rocket City, I think, is doing a four-panel. I think that's what you said?
I think so.
Okay. Let's color correct this to get our curves all aligned. Color correct this way. That kind of showcases where the cloud is. So let's do the normal palette. Okay. Wait for a few more to come in. If I don't miss my guess, this is one of Izabela's favorite songs. Gymnopedia. If you'll pardon me 1 minute, I'll let this song play while we bring in some stuff, and I will go get myself a bottle of water. Can you hang on for a minute?
Sure.
All right, I'll be right back.
I don't hear any music. Then I never do. If we're in that part of the sky, maybe Mark could show us California Nebula. Just a thought.
Here in the observatory bunker, we're well stocked. And Izabela says, yes, it is. All right, let's see what else is here. It's a little early to try this one, but we'll try it. And you can see the streaks and the darks. One of the interesting things with the dark nebula too, guys, is in fact we can do this right now. Let me get rid of the telescope here for now, and let me drop this down, let that crank away, and let's enlarge this. Looks like we're taking a picture of a cloudy night sky, but we're not. You can see these tendrils of dark nebula coming through. You can see this subtle nebula in here. That is really impressive. But I want to point something out to you. Okay. If you look, you can see that these stars look a little redder than normal. I mean, you can see that the stars in here, that's red. That's very red, right? And so this guy up here is red too. Now, why are those red? It comes down to the fact that we're looking at these stars through dust. And just like in our atmosphere, when you look at the setting sun, you're looking at it through atmosphere, molecules. Well, we're looking through molecules as well, molecules of dust. And this dust is reddening the light that we're seeing from the stars. So the stars may be red dwarfs or red stars for sure. Some of them probably are. But the light is also made redder by the dust if the stars are inside the dust. Okay, so that's what we see when we look out in the universe. We see a lot of this happening. Let me see if I can quickly adjust our levels here to start showing off some of the differences. Yeah, that's better. Look at that. And here you can see very clearly the stars are definitely red tinged in here. Now, again, they could be red dwarf stars, which are red. But in addition, the light is further reddened. This area right here is particularly interesting. And I'm going to zoom in on that. It won't be perfect, but I'll show you. As we zoom in here, you'll notice that there's a red star here, but there's also this kind of a reddish haze around here. Okay? Now, what's happening is very likely that there is also hydrogen mixed into this dust, and some of it's ionized and some of it's not. And so we're seeing a very subtle red diffuse nebula here. So that's something to consider, that you have a mix of the dark dust with hydrogen gas, which will give you these different nebulae. And all a nebula is a cloud. That's what it means. It's a cloud. You know. Wow, this is really cool. Salute, universe. Rocket City says, I need a new Galaxy scope for this year. Who's got a winning lotto ticket? Yeah, well, what you're saying is you need a high focal length telescope. Yes, that might be true, but then that means you need a very high-end camera to record less light and not be noisy. So you need a thermoelectrically cooled camera. We're using one of those.
Photon just asked about that.
Okay.
Imager seems rather noisy tonight. Is it cooled?
Yeah, when you do dark nebula, that you're going to see that we're at minus 20 Celsius right now. Yeah. Plus, if you consider where I'm actually at my processing, I've actually got this kind of punched up a little. It should really be more down here if I want to be fair about it. Okay, so this is where it should be, but if I punch up my processing, okay, I could actually make it look very noisy. Okay, like that. That's very noisy. But I was doing like around here, but we're gonna really do it down here, to be fair. Yeah. Now, if I wanted to alleviate some of that, see, I have the unsharp masking off. If I turn it on, it will enhance the details in the subtle dark clouds, but it will also enhance the noise a little bit. But I can get around that by turning on a bilateral filter, and I have this setting which seems to work. And then the bilateral filter helps weed out the noise. So now it looks more smooth and pretty. I like it. Nicey nice.
I'm looking at an image of Barnard 22 and IC 2087, which I assume is that bright thing you were looking at earlier.
Mm-hmm.
Boy, the
It's
entire
1527 LDN 1527 too.
the entire image is very complicated. It looks like some kind of a fancy insect or something.
Mm-hmm.
Really bizarre looking.
Now, what's interesting is a lot of that detail is buried in here, and we can get it out. We just have to tease it out in the processing. Alright, so... Okay, let's do this. Let's see if we can do a little bit more of a tease now. Hey there, Papa Tom. All right. Okay, we are just at 20, the same as before. So let's save that. Save exactly as seen. Alright, and that's the extent of this cloud tonight that we'll do. Let's bring the telescope back into the view. Okay, here we go. I love my gestures. I just think that's the coolest thing. Alright. Now, and let's do this. Let's come back to our low light view. I'm going to first things first. I'm going to get rid of this here. We don't need this now. Okay. All right. And back here. All right, there we are. All right, so now that we're in this region, I'm thinking we should probably check this guy out. No, not that guy.
What's crab?
Yeah, I hit the wrong one.
It's right above.
LNAV?
No, that's the wrong one.
Oh, it's this guy right here.
That's right there.
Yeah, okay, so I just hit the wrong one. Okay. So let's check out the Crab Nebula then. And Orion is starting to show up. It's starting to come up, but we're going to see if we can see this yet. Here we are. So let's do now. I'm going to get my... There's Barnard's loop. Oh, wow. Well, we're close. Actually, we're actually close to be able to image some stuff there. Okay. Let's do the Crab Nebula, and by the time we're done with that, we should be able to image Orion. Alrighty. I think this is going to be pretty. Actually, I know it's going to be pretty. The colors and detail in the Crab Nebula are really amazing. This is a remnant of a star that blew up in 1054 AD. Chinese astronomers saw it, and it became a real bright star in the daytime sky that could be seen. Similar thing that Betelgeuse will become once it goes. So, got that. And the entire guts of the star was just blasted out. And this does not require a very long exposure to show tremendous detail. So I'm actually... We're going to do 20 seconds. That's all we need. Don't need any more. So we'll minimize this, get out of that low light mode. There's the cloud. That's probably up on the server already. Okay, we'll just dock this back up because we don't need it to be undocked right now. Here's our first shot. Look at that. Already looking really, really something. All right, and color correct the sky.
Nice.
Well, it is. Look at the filaments. All right. Look at that. Pull something just behind the leading edge. Look at that. Isn't that crazy? That's a beautiful nebula. And right there in the center, right there, that guy right there, and I'll show it to you even clearer. Right. Inside this box, you see that little white star? It's actually blue. That's called a pulsar. It's a neutron star that's rapidly spinning and hitting us with hot spots as it rotates. We're getting and it's happening 33 times per second. So this star is spinning at 33 times per second. It's a star the size of Manhattan Island. All right, and it's spinning so fast. And the thing is, at the speed it's spinning, you'd think it'd be tearing itself apart. But the gravitational field inside the neutron star is so high, it literally is holding the star together. Now, it wants to squeeze it even further down, smaller, but because the star is made up almost exclusively of neutron particles, neutrons that are slammed together so hard, they have a repulsive force against each other effectively called neutron degeneracy pressure. And it's that force which prevents the star from being shrunk further. All right? So, like with white dwarfs, they're not neutron stars, but they have carbon and oxygen nuclei on their surfaces, and the electrons are separate from the carbon and the oxygen nuclei, and the electrons are being squeezed as hard as they can, and you can't squeeze them down beyond a certain amount unless you have much higher pressures. But what we're looking at here, in that case, the white dwarf, is electron degeneracy pressure. So the force of the electrons pushing against the other electrons nearby keep the star from collapsing further. It's pretty interesting. It's like a checkerboard where you can only have one electron per square on a checkerboard, and they won't squeeze any further than that, right? Similar with neutron stars. You can only have one neutron per checkerboard square, and they can't squeeze any further. So the electron degeneracy pressure holds up the white dwarf. Neutron degeneracy pressure holds up the neutron star. And we're seeing a neutron star right there.
If you consider, as Mark said a bit ago, that neutron star is about as big as Manhattan Island. It's 6,500 light years away, and we can see it.
That means a great deal.
Django has a question of you.
All right, Django. Oh.
Brigitte. Brigitte, you are part of the Rebel Alliance and a traitor. Take her away. I think the Force is strong in this one.
That was pretty good, wasn't it? It's the bottle, the Vader bottle. Wow, this is really pretty. This is coming out so nice.
Yeah.
Now there's colors, okay, just as we've spoken about before. Okay, the colors, okay, we have a hydrogen gas that's been excited by this very, very, very hot pulsar in the center. Tens of thousands of Kelvin emanating from that central core. This is the expanding debris cloud of the supernova. It's just literally expanding out into space. In over 100 years, we've actually photographed this for over 100 years, and we could see this expanding over 100 years. You can actually watch the expansion. And there's a little movie out there that shows you this. The green clouds here are ionized oxygen, doubly ionized oxygen. And that's a characteristic color of ionized oxygen. Boy, this is something. We can zoom in even more now.
Please.
Look at this. All right, we're at 100% on our sensor, so this would be the maximum that our sensor. This is a natural. This is a native. The native resolution of our sensor right now. I'm going to pull this down just a little. Color correct.
What would the unsharp mask do to this? Or is it already on?
It's already on. If I turn it off, I'll show you what it does. right, you turn it off a little bit. You see how muddy this looks down here?
Yeah.
Okay, now watch me turn it on. I only have it at 1.5. But look what it does now. It highlights all these beautiful filaments very, very nicely in a way you just could not see before. See that? So let's turn it off again, do a comparison. Okay. Now, this is kind of muddy in here, right? See how muddy that is? But we want to straighten it up and fly right. Look at that. Just throw that on. Now that's sharp. If we go to, say, 2, now it's even more pronounced. Look at that. Yeah, really, 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 really pretty. Now, our stars, we've been way higher on our full width half maximum setting. So we can drop this down even more, probably right to 6.45. We've been just over 5.8, so we're getting really, really good stars. Guiding is perfect, relatively speaking. But there it is. Look at the Crab Nebula. Holy cow. That is something else.
When we see the entire nebula, it's about 5.5 light years across. And yet we can still see Manhattan Island shining down there in the middle of it.
Incredible. To think that it's so bright that it's visible from 6,000 light years away. That's just incredible. Yeah. Okay, we've done 23 of these. We'll go to 25. That'll be fairly quick because it's only a 20-second shot. And then we'll save it. My God. I'll tell you. Really pretty. Now, you remember when we looked at the Perseus cloud? You saw that those dark nebula? Or the Taurus cloud, I mean? That looks subtle and pillowy. Okay. That debris was born of a supernova at one point. Now imagine this just spreading out and spreading out and spreading out until it's far away from the pulsar, and the pulsar doesn't affect the gas anymore, but the dust that's being pushed out may have been in the outer atmosphere of the star before it went supernova, possibly, or formed afterwards along the way. That's something that is really, we're seeing an example of what has happened in the galaxy billions upon billions of times. Long before the sun was here, the galaxy was populated with this dark dust from these continual supernova explosions. So that's, Ginka says it well, it's mind-numbing. But it's true. It's true. You do not want to be anywhere near this because the radiation it's giving off would sterilize anything that it's coming in contact with. However, with the death of a star comes new life because as it pushes outward, it's sending out this material at high speed. That material hits other material and it creates a shock wave, a bow shock, right? And it compresses the material, causing some of it to start contracting. And as it starts to contract, it may form a star and a set of planets that could then harbor new life a few billion years later. So that's what's going on here. This is something that's just, it never ceases to amaze me, and it never ceases to impress me that we're literally looking at the universe doing a recycling run. That's what this is.
You zoom in on that just a little more.
Now, let me save it all here. Okay. Yeah. Let's go in. In fact, let's go in a stupid amount. Let's go in stupid zoom.
Well, if you consider now 5.5 light years from lower left to upper right, or vice versa. Okay, that's what is it, 6.6 trillion miles per light year?
Yeah.
So you're looking at maybe 35 trillion miles across, and yet that little dot in the middle is 3 miles across, and we can still see it. That just blows my mind.
Yeah. Now it's obviously wildly bloated in size. Okay. And that's because it's very, very hot, and it's bright to the sensor, so the sensor bloats the image.
Yeah.
Okay, and we have the atmosphere to thank for a lot of this too. If we were looking at it without atmosphere, this would be so crystal clear, it would just you would say, where'd our atmosphere go? You know. But yeah, really impressive. And like I said, we can zoom in endlessly here. Now we're inside the Crab Nebula. Look at the detail inside here. That's pretty impressive. You can see the individual pixels now in the camera.
Some quite dark areas in there too.
Yeah, look at this. This is really interesting.
To the left, would you back out some?
Right here.
Yeah.
Yeah. Look at that. Looks like some of the nebulae we've looked at. Let's do another color correction. Make sure that we're okay here. And we are. Wow, that's neat. Okay. One more save. And one more exactly as seen. Nice. Good music for this too. Eerie. Strange place in the universe. Alright. Okay, it's all saved. We're gonna come back now. There we go. The Crab Nebula. As a kid, I never felt like it looked like a crab. But, what do I know? Let's see if we can image the Horsehead yet. Barnard 33. Telescope's going to go toward that wall, and it might take it just a little bit low, but we're going to find out. Think we could just grab the Horsehead. Not sure about the Orion Nebula yet, but we'll see. Horsehead's right here. This is Sigma Orionis.
My favorite multiple star.
Yep. Now I'm going to just drop us down.
I'd have to look that up. That's like 6 or 8 stars all zipping around real close to each other.
Yeah, I think spectroscopic binaries abound here. A couple of them. It's several pairs, I think. Okay. That's pretty cool. We're going to just drop this down a little more. I'd rather not get Alnatak in this shot, so I'll just bring it back up. Alnatak is the leftmost star in Orion's belt. Okay, there we go. Now I'll move us back to the east a little bit. You'll see why. You're going to see a great wall of red here, which is just stunning. Now, Sigma Orionis here is a very, very hot star, and actually several hot stars. So it is ionizing a lot of the hydrogen, and you're going to look at this and say, wow, that looks like a wall. And it really is a wall. There's a lot of dark nebula in here. In fact, this whole region is dusty. You can see the dust around the stars. Look at that. The stars are actually dusty looking. And you'll see this in just a sec. So let's do this as a straight up 25-second shot. We don't have to go any more than that. We're guiding, and we'll come out of our low light mode and jump into the stack and get rid of this last image we just saw, the crab. That's beautiful. Holy cow, look at that. One more zoom. Wow. That's nice. All right. Now on to the Horsehead Nebula. Coming right up. I hope. If I full with F maximum, probably a little high, so I got to bring that down. Yeah, see, 8.48. Let's bring it up to the threshold. All right, let's try that. 8.64. There we go. Look at the Horsehead. Let's zoom out. Look at that beautiful scene, guys. Color correct. Curves are good. Let's do the processing. Wow. Now that's really pretty. And you'll see on this left side, this is going to develop into a pillowy looking cloud. And here's the wall I told you about. It looks like a little wall. And Sigma Orionis is actually lighting this up with its ultraviolet radiation.
And when we look at the wall, we're looking at it kind of end on, aren't we? Where it's actually moving away from us in 3D.
And very good point. The universe is in 3D, as Daryl says. So, in terms of everything we see, this section of the wall here, you know what I'm gonna do? First of all, let's do this right. Let's get rid of this guy. We'll stack in the background, and let's go get rid of this stuff and pull us up full size just to make it beautiful. There we go. So as Daryl rightly says, okay, this wall stuff we're seeing right here that goes all the way up and down, we're not sure of the actual physical geometry there, but that wall could be going around into the background. So maybe this material here is sort of facing us and curling around and going behind on the backside. And you'll see that puts this star either a little closer to us, a little farther away. Either way will work. But for data come in, we're going to see some really interesting details in here. We're already seeing some here. Let's check this out. Watch this. As we pull into this, okay, we're seeing a star in here. We're seeing a dark nebula chunk in here and here. And you'll notice that the dark nebula is being it's being hit by the starlight, and the starlight's being scattered. The blue component of the starlight is scattered in every direction, and that's why you see the blue nebula here. And it's embedded in this dark nebula, and this piece is in front of the star, and the star is behind it, and so it's kind of getting into the field of view, so it's silhouetted by the other nebulae that are actually causing this to be illuminated.
Looks like a faint tendril
It does.
trailing off above that darker, thicker section there to the left.
Yeah, I think that's...
Going clean up to about 11 o'clock where it gets thick again.
You mean here?
No, the thing, that right there, the thing on the left.
Yeah, that.
And then going straight up from the top of that.
Oh, yeah, it looks like it has more in here. Now, see, what's interesting is... This is, again, with the other camera we were using, this was not visible to us. This new camera is specifically tuned to this scope, so we actually are seeing more detail here than we're used to seeing. Well, that's really pretty. This is the first time I've imaged this with this kind of with this camera. It's beautiful. Let me see if I could pull out some more detail here.
Very three-dimensional.
It is.
Reminds me of, I don't know, an old Gustave Doré image or something. It's like looking up in the clouds, tunneling toward heaven or something.
Exactly. It looks like we're drilling down into this, doesn't it? And then coming to the Horsehead. Okay. We zoom in here. We can see that there is a star here. There's a faint bluish gray patch over it. There's a opening here in the dark nebula where you can see the ionized hydrogen behind. And there's other faint stars in here as well. This is nice. Let me see if I can... I want to get rid of the bilateral filter. Okay. By getting rid of the bilateral filter, we see a little bit more noise, but we also get to see more detail. Okay, let's take this down a little bit. That's nice. Beautiful. I mean, that right there is a good, beautiful composition right there. These two things. Beautiful. Beautiful, beautiful. Lest we forget this one as well. Let's zoom in on that. Wow. There's a lot of ripply detail in here too that we've never caught before, really. Again, red stars, guys. These red stars are embedded in this dark dust. So, I would say the stars may not be as red as we're looking. They certainly aren't as red as we're seeing. Even if they are red stars, they're made to look redder because of the dark dust doing that to them. Stars that are nearer to us are going to look brighter and not have that problem. Okay. That's really nice. Let's go to the full frame. This is one interesting region of the sky, huh?
Putting it mildly.
And this is all happening live in real time, guys. Live in real time. Izabela, this is the new camera. Yeah, we got a lot more pixels to play with, man. Okay, let's dock this anyway. Okay, we have 17 shots. We'll go to 20. And then we should be able to get to the Orion Nebula region. It's just south of here.
Yeah.
We'll save the
I
flame
always
for another
see-
night.
I'm sorry.
We'll save the flame for another night.
I always see the wall there
Yeah.
and the horse head. Just above the horse head, it looks like a sharper angle, kind of edge on, like you're looking at a corner, almost edge on to the part above.
This here?
Well, all the way down to the horse head.
Yeah.
And then as you drop below the horse head, it looks like the wall is kind of curving more toward us,
Toward us, yeah. Yeah.
like there.
Now that could be an illusion or it could be real.
Yeah, and Sigma there. I think, or I get the feeling, it's a little farther in, illuminating the wall, and then the horse head is a little bit closer to us,
We'd have to look that up.
helping silhouette it.
But now that, see, that's a nice thing though to bring up because, see where Sigma is. Sigma is also getting some of its light scattered by the Horsehead Nebula. So, in the top of the Horsehead Nebula, you'll notice there's this lighter patch. What's going on? Stop. There's this lighter patch up here. This lighter patch is actually a lighter patch of bluish scattered light from Sigma. Wow, look at this. This is really showing some really interesting detail in here.
Is that a double star inside that cloud?
I see a star there. I'm not sure
Yes.
if that goes with here or if that's just line of sight thing. We'd have to look that up. Sinbad will tell us, or you could just probably find out. Okay, we're gonna go to 25 shots of this. Oh, that's weird. That's a weird looking view. Alright. So back to the Horsehead now.
I've never seen Stellarium go out of focus before.
Isn't that wild? That's weird. Never saw it do that. Stellarium can't go out of focus. Wow, that's neat. Oh, it's a graphic anomaly, not a big deal. Alright. Okay. Oh, yes, we got all kinds of things to do here. Alright, so, back here, and looking inside here, let's take a look. Oh, that's called the Lump Star? Lump Star? Wow. I didn't know that it even had a name. How about that? Wow, our image looks better than this. Here's our image. Okay. And the Stellarium image of the same thing. Right here. Ours is better. That's something. Wow. Neato. Alright, well. Now, let's go to that big ticket item we've been waiting for. By the way, you'll notice some really cool additional nebulae here. Okay. Including what could be some globules that are condensing gravitationally to form new stars and or planetary systems. Look at that. That's incredible. Let me try one last thing here. I'm going to jump up to 2.5. Okay, a little. That's 2.5. We're going right to 3. Look at the detail showing up in the back of the horse head here. Look at all this. This is actually really nice. That's incredible. So we turn it off. And it gets very soft. Turn it on.
See another star in the nose of the horse.
Yeah. Talking about this guy?
Yes.
Yeah, we got that one. We've got that one. We've got that one. Look at that wispy structure. That's something we've not been able to recover before. Look at that. Beautiful structure in there, Daryl. All right. Well, so what we'll do is we're going to save this. And save it exactly as seen. Oh, sorry. I screwed up.
Yeah.
All right. I'll do it now. Barnard
Horsehead.
33. Okay. Let's see what I did here. All right. And then... Okay. Well, if the directory structure is messed up, I can fix it. Okay. And now, let's go and check out our premier object if it's up high enough, which I think it is. First things first, let's get our telescope back in the view here. There we go. All right. So much detail there, and look at what you get. That's about all you can see. A small telescope, this is all you'd see. Maybe a little fuzziness. Amazing what's really there, huh? Okay, now I think we're going to be just high enough to capture the most beautiful of all objects, the Orion Nebula. The Great Nebula in Orion. It's got to go south a little bit, so it shouldn't have any trouble finding it. And here it is. Very nice. Okay, so now we'll head eastward.
There you go.
Who's telescope lady?
Renee Cruz mentioned some telescope lady, and then she said Terra or something like that.
Artera?
I don't know.
That could be Artera, who does all of our maintenance with Marianne.
I would assume maybe that's it.
All right. Okay, well, we're going to leave this so we can actually see a little bit more down here. Because because it captures a little more down here, okay? That's good. All right. So, first things first, let's show you what's going on in here. Again, some really pretty music for this. This is a beautiful nebula. About 1,500 light years away. About 23 to 24 light years across. And no, your eyes aren't deceiving you. There is a little satellite traveling through here. It's right there. Yeah. They're following each other. Those might be geostationary satellites.
Yeah.
But we're following the objects, not the geostationaries. If we track those, then everything will... If we actually stop tracking, they should stop. Let's do that. I'm turning off tracking. So the nebula is going to move, and those should stay still.
Yep.
There's one right there. Notice at the end of my pointer?
Oh, that one pair is a little farther to the left.
Yeah, I see that. That's like there's one here.
Two.
Oh, what happened there? Oh, ha. The Starlock is trying to reacquire. But you see those two right there? Okay. I could turn Starlock off and it would work. What you're seeing though, right there, is you're actually watching how there's satellites that are over one spot on the Earth. The stars are rotating with the Earth, right, as we move with the Earth. But the satellites are moving over the same spot on the Earth. So what we do is we actually find ourselves either tracking the satellites or tracking the stars. When you track the satellites, they stay still. And that's how you know it's a geostationary satellite, because they don't move. Okay.
Yep. I see Bill Murray eating the baby Ruth.
Oh, you keep saying that. One
Yeah,
of these
well,
days.
it's short exposure to see it.
Yeah. Okay, we're going to try something here. I'm going to drop the gain down. Drop it way down. Okay. And I'm going to drop the exposure down as well. There's a reason I'm doing that. I'm going to show you. Actually, I didn't have to do this. I just had to do this. Okay. Now I know you see nothing. Just give me a moment. Let's get our exposure up to... I don't want that. I want to do 1 second. Okay. So now, I'll come up one level on the gain too. Gain's at 100. Go to 150. Okay. So now if I zoom in, you'll see what powers this nebula. Okay, and it's the trapezium here. Now this shows us right now that we're just a little out of focus, which is good because I want to check that.
No.
And I believe if I do this, it's gonna... Right, that's what I thought. Okay, so we're gonna go in like this way. Okay, one more level. One more. There you see the 4 stars. These are the trapezium stars. These 4 hot young stars are actually powering this entire nebula. Okay, but to get a picture of them, look what happens. You gotta literally, totally, completely remove the nebula brightness. If you even bring it up a little bit, you lose the trapezium. There they are. They're just barely in there. Okay? That's pretty cool. So here's what we're going to do. We're going to do an amazingly crazy thing. We're going to go to 25 seconds. And we're going to do a 25-second shot here. Why? Because I'm going to show you what hides amongst the nebula here. It's not just nebula we're seeing. We're on the verge and the edge of a gigantic molecular cloud complex. See all this dark nebula here? This is all dark stuff. Well, there's plenty of that around the entire Orion Nebula in that whole region. So we're going to zoom out and catch it. Daryl's taking his drugs. All right, so
Mark,
there...
Excuse me a moment, please.
Yeah, so you see the entire nebula, but we're gonna get it up right. Now watch this. See all that dust? Look at that. We'll color correct this. All right, now we're gonna move our white level in. Look at all the details showing up just out of nowhere. That's incredible. And you're going to see all kinds of additional detail in here as we start to develop more. So you see, we have to lose the center of the nebula to show you all this other detail in here. Amazing stuff. Look at that. Measure 43. This is 42. This is 43. Dark cloud. This stuff extends all the way out. All the way outside here. So if we zoom out of this, if I were to use this other histogram to lock this up a little bit more, you can start to see there's all this additional dust out here. See it? And we can do it this way too. Okay, so now you see all this other dust out here. There's tons of it. Alright, so that said, this is what the Orion region actually looks like. Right? And this is what you see in your telescopes. What you never get to see, though, is all of this dust. And we're going to go up to 200 gain here and clear it and come back and just redo this. Alright. There we go. That line, that's one of those geostationary satellites that we saw before. But we're tracking the stars now, so they look like they're moving because the Earth's rotating, and the stars are rotating out from under the satellites as well. Or rotating out beyond them, of course. Okay, so we clear this. There's our new version. Lots of dust in the universe. See that? Let's do this. What a gorgeous view. Look at that. You're looking at all the hydrogen emission here. This is known as an emission nebula. Okay, because we see this very, very convoluted hydrogen-rich area being ionized. This stuff here is a combination of dust mixed with ionized oxygen. And the ionized oxygen is not ionized just once, but twice. And that's known as O3. O and the Roman numeral 3. Okay. Dust everywhere. Now you look over here and you say, well, there's nothing much going on over here, is there? Or over here, right? Well, not true. Because if we were to kick this up quite a few notches, then you'll see that there's lots of dust in here. Right? This trails off to here. You can see more dust in here. Wisps. Just incredible. And this is your Orion Nebula. One of the few nebula you can actually see with your eyes. The unaided eye.
Well, you had it in field. The red teardrop shape just going off the right edge of the screen now.
This guy right here? Messier
No,
43?
the red, yes, Messier 43. I mean,
Look
the
at
big
this.
one is 42, and then that one right there is 43, correct?
Yes. That's right. And if we play with our settings, we can probably get a little of the noise reduced. There you go. Look at that. It looks like a painting. Now, let me show you something. Let me back out a bit. Okay. Getting little artifacts here, but we'll get it back in a sec. Okay, so it looks like this is just empty space here. This is not. This is actually the giant molecular cloud complex. This is dark nebula back here. Okay. The Orion Nebula is like a blister within this dark nebula and this Orion Molecular Cloud Complex, the OMCC. So when we see this, it's a star-forming region. We know these are called stellar nurseries for a reason, because they foster young hot stars. In fact, it's the creation of the young hot stars from within this originally dark dust and gas that causes the nebula to then glow. So the stars came first, then the nebula was the result of the stars' hot energy, ionizing the gas all around them. Incredible, isn't it? And we're seeing such richness of detail with this camera that we just did not see before. Little gossamer streaks right here. This is beautiful.
Look at the green streamers there toward the lower right.
Yeah, right
Lower
here.
right. That right there.
Yeah. See, those are oxygen gas that has been ionized, doubly ionized. That's the O3 sections. And it's mixed with dark nebula. It's mixed with little reflection nebulae. Some of these are reflection nebulae as well. And some of it is just illuminated dust from the starlight. And like this, the brown stuff, that's all just illuminated dust. Now the red stuff is imagine being here. Imagine taking a ship and coming through here. Now, you would see the stars, and you might see to your eye, you might see a subtle glow, right? You might see a subtle glow. Hey, Curtis Horn's here. Hey, Curtis. You might see a subtle glow to your eye, but you probably wouldn't see the nebula that you see here. We are 1,500 light years away. The farther away you are from a nebula, the smaller and more compact it is. And thus, consequently, the brighter it might appear in your telescope. Okay? But if you were there, you might not even know you're in a nebula. You might not even know. Let's punch this up at this end, just to show you a little bit more of the gossamer streaks out here. Watch this. Look at that. The stuff out here. Look at that. There's such detail out here. You know, and it's not where it ends, because look, there's more right here. And look at this. It looks like you're looking through clouds. These are areas illuminated by the stars, and the dust isn't technically scattering anything. It's simply reflecting the light of the stars. That's incredible.
If you looked at the entire constellation of Orion, much of it is all the Great Molecular Cloud.
Yeah. Now, the famous Barnard's Loop that we're familiar with, it's a large arching diffuse red nebula to the left side, arcing up the left side of Orion. That's an ancient supernova remnant. Now look, we got 15 frames, and look at all the detail here. Look at this. What am I doing? I'm totally, I'm get rid of this. Jeez, you know, come on, guys, you gotta remind me to do this. Get rid of that, and let's get us a nice view. Here we go. Look at this nebula. Wow.
Boy, a lot of satellites.
Yeah, those are the geostationary birds like we mentioned earlier,
Yes.
as you know, yeah.
More on the left.
Yeah. Look at this. This region is always astonishing to me. The amount of detail in here and the complexity of what's going on in here. That's so pretty.
I assume with all the geostationary satellites, we must be looking at or very near the
Equator.
equator,
Yeah.
celestial equator.
Yeah, so yeah, they're not exactly on the celestial equator, but where we are right now, okay, looking in Orion, let's go back to Orion. All right, we're at a declination here of just about -5 degrees, right? So this, you know, the celestial equator is just right here, so we are close without a doubt. Let me get rid of this to release the confusion here. Okay. All right, so celestial equator. Let me just drag this down and show you. Okay, celestial equator's here.
Yeah.
All right, so this is -1, -2, -3, -4, and -5. So we're gonna have geosynchronous satellites all through this band. And that's what we get. Wow, man. Look at this. I mean, look at this. Look at the detail and intricacy in this area right here. Look at that. And look at right here. I mean, I can't say it enough. This detail in here is astonishing. Again, not visible to us with the last camera. Far and away the better choice for this telescope system. Wow. Yes, Renee Cruz. That's actually that's a very fascinating way to look at things. She mentions all the quintillion of Earths out there. Here, let's see if we can get rid of just a little more noise.
That's getting into philosophy.
Yeah.
I've heard it discussed before about if there's life out there. Religion starts overlapping too. That
Yeah.
would other life out there be living in a state of grace?
Yeah,
Then you're getting into original sin and stuff like that.
yeah. I'm not
Which-
sure
I think is beyond the scope of this discussion.
Sure is. No one's qualified to talk about any of that. Look at the Orion Nebula, guys. And just above it is the Running Man Nebula. And I have to say, that's just beautiful. Wow. The Running Man is out of the shot. Okay. I'm pretty sure this is going to be... Yeah, 26 images. And I'm going to change the name now. M42. Orion Nebula.
I think I'm going to call it a night, Mark.
Okay. Fair enough. I'll do the same.
All right.
So we'll save this at 27 frames. Save it exactly as seen. So what you'll see...
satellite streaks in there.
I know. Well, we can get rid of those. Here's the picture that's on the server. Right? Michael Hedrick, I agree. It's really among the most beautiful images we could ever show. The Orion Nebula. That's the image, by the way, that you actually get on the server when you go up there and grab it. That's the one. Alright. So let's dock up this. Let's bring back my telescope here. Alright. I almost don't want to leave it. I mean, I'm astonished by how much details in this little guy right here, Daryl. This area right here.
Looks like a rabbit.
So it does. So much detail in there.
Or like a guy leaning forward at the waist.
Yeah, yeah. With a cowboy hat on. He's bellying up to the Orion bar. Look at that. That's so cool. All right. Well, guys, what a way to end the night, huh? With this beautiful nebula. And it's going to serve us well, because we're going to see it a lot more. I want to thank everybody for coming out. Make sure, please, become one of our become one of our patrons, okay? These are our patrons right now, and we need a lot more patrons to keep going. And I would really hope that you would join our Patreon, and become our Patreon member, and just support what we do. We have an awful lot going on. We have an awful lot to do further. We're working on plans to install the new telescope in another location out there. I'll be out there in January scouting that location. And then the East Coast telescope is going to be back up and running after that. And the organization, SkyTour Livestream, that we started, is actually working on a mobile telescope system to take to campuses and schools all over the country and show people the night sky live from their backyard in ways they've never seen the night sky before. So that's what we're looking to do. And we have a long way to go, but I think it's a pretty honorable approach. And now don't forget, in conjunction with Calybos here, who is our friend Mike, we are going to help Calybos give away multiple telescopes and possibly binoculars and small night vision systems, among other things. So we're going to design the contest and the way in which you can enter it here in the next several days to a week or so. All right? And so you guys take care, and make sure, by the way, I think it would be really cool if you'd take the chance to head on up to our Etsy store up there in the upper right corner. It's called SkyTour Shop on Etsy. And you like pictures like this? Imagine them on a giant blanket, or on a mug or on a mouse pad. We have them up there. All right, and they're all there for you, and all the proceeds go to support what we do. I don't get any of it. It's all just to help us further the education in astronomy. Because when you see something like this, once you go Orion, you never go crying. Okay, it's just beautiful. So thanks for coming, guys, and we will see you again soon. Good night, everybody that said good night. Thank you so much, and we'll check you out on the next clear night that we stream. So have a good night, everybody.
Good night, everybody.